conference will now be recorded.
Yes. Good morning, everyone. Good morning, everyone. There is Good morning, everyone. Screen and audio both are fine or not? Please confirm.
Morning.
Screen and audio both are fine or not? Please confirm.
We- Yeah, it's fine. Yeah. Thank you.
So this is the demo session for physical design. So this is like a introduction session so that you can understand the coursework which is followed in this institute and how we are going to proceed with the course and what is going to happen after the course, right? And what are all the opportunities with respect to placement. So everything will be discussed here in this demo session. When classes will be scheduled, which class will be scheduled, how course pattern will go, everything will be discussed regarding materials which is given, regarding test which will be taken, right? Everything will be covered in this demo session. So here we are going to follow complete course structure. So how and things will be going towards placement support and interview preparation. We'll discuss some of the basic concepts also, which is related to the VLSI design, right? Chip design. So you are a graduate or postgraduate, graduate. So chip design versus chip fabrication, a SIG design flow, advanced physical design concept, and we'll discuss how things happen after a design is completed, right? We'll give just a brief on all these topics. So many of you here are maybe graduates, maybe freshers, right? Many of you are MTech postgraduate. Many of you are maybe working or non-working or maybe working in different fields. So this pool consists of different people here, right? So I just like to know, like out of people who are present online here, right? Out of 18 people, how many are fresh graduates? Please, you can type in chat box. How many are fresh graduates? How many are MTech in VLSI design? And how many are working in IT or computers or some other domain or maybe some another physical design, I mean VLSI design domain. So please mention it in chat box so that I can understand. Okay. Anything you have already told. So if you are working in another domain like computer science, IT, right? Networking. If you are having branch of electrical and electronics, electrical and communication, electronics and communication, that also you can mention. If you are working in mechanical engineering, if you are part of mechanical engineering, you have done your graduation in mechanical, or you have done your graduation in civil, that also you can mention. Okay, so that's all. 25 pass out, 25. Anyone who is there before 25 graduate, apart from working people who is not working in that group, anyone who is before 2025, 24, 20, before 2025, 24, 23, 22 or 21. Okay, so I am working in, okay. Yeah, apart from working people, so many are there who are from working, it seems. Okay. So yes, so we'll continue. So if anyone who is there who is non-working, who has a pass out year before 2025, it may be 24, 23, 21, 20, 19, 18, 17, 16, 15, any number, right? If you have, you can mention. Anyone from PhD, that also you can mention, so that we can understand which person lies where, right? According to that, we will be helping you. So physical design course starts with the structure here, which is shown here in this PPT. You can see that it is a 6 months duration course. So the first part of this course will be for 2.5 months, 2.5 months. That will be for PD basics. The rest of the part, which will be like 3 to 4 months, will be constituting to the PD advanced course, where you are going to learn dedicatedly concepts and lab support and your hands-on development, which is related to PD advanced topics only, which is dedicated for physical design learning. The first part, PD basics, right? First part in the 6 month, what you are going to learn. Yeah, please mute. The first part in PD basics. So what you are, so many who are there who are fresher, who are working in different fields, maybe some IT, maybe some railway signaling, right? Or maybe some different domain. Now they have a gap between what they have learned in first year or second year or third year. So many subjects you are not able to, you haven't revised those subjects. Now you need to do some brush up and revision, right? For that reason only, so that everyone be there in same platform in one sync. That is the reason PD basics has been included in this structure. So what we are going to cover in this PD basics, right? So first, so in VLSI design, we don't need to cover all the basic subject what you have learned in electronic design engineering in your graduation level, right? So basically you need to cover digital basics, that is must, right? Digital basic means digital system design, right? Then you need to understand CMOS basics. CMOS is also very core and base of VLSI design. You should be good in basics. Then comes physical design basics, means what kind of flow we are going to follow in physical design. So basically, the from graduation, if you want me to ask, like, what is the thing, what are the subject which we are going to learn from the graduation part, right? Those are digital and CMOS. If you have completed these two subjects very nicely, so your basics are completed. Apart from this, if you want to clear some test or exam, then you should study network and network theory, signal and system, right? But those are not directly linked with VLSI design. Main subject which will be helping you in VLSI design is digital basic. CMOS basics is must. You should not ignore these subjects, right? Next, apart from this, you are also going to get the hands-on EDA tool, right? Which is the industry level license tool. EDA tool means electronic design automation tool, which will be helpful for you to get a job, to get a good opportunity in the VLSI industry. So for that, you need to be acquainted with the tools or the skills which will be helpful in using those EDA tools. So the platform usually it is followed for these tools are GVim basics, right? The platform is Linux, right? For that, you need to understand few text editor skills. So GVim basics are nothing but text editor skills. So you also need to acquaint with the Unix commands, right, which will be frequently used in these platforms because the industry works in the Unix based platform, right? Then we will also teach you, right, those that is tickle basics. What is tickle or TCL basics? Tool command language. It is nothing but a scripting language. So if you know some scripting language, it will be always a plus point for you, or advantage for you. It is not the mandatory we are saying, right? It is not the mandatory to learn, but it is always helpful in your skill development or in the industry while working in any project, right? So mandatory things which is must compulsory you should definitely learn is digital basics and CMOS basics. That is must, right? Then only you will be eligible to move to learn physical design concepts or physical design advanced concepts. Clear? So what is the class timing here and what are the learning resources we are going to give? So class timings will be on daily basis. It will be conducted on weekdays as well as weekends. Okay. So on weekdays from Monday to Saturday, it will be 3 hours. In weekends, it will be Saturday to Sunday, 3 hours again. So each class will be at least for 3 hours. Clear everyone? Provided that there will be some 10 minutes, 10 to 20 minutes of break in each session, right? So learning resources will be provided for PD Basics, right? We will also give you printed materials. Each and every session will be recorded. The live sessions will be recorded, and that recorded session will be uploaded in the your student user ID link, right? Where you can access those videos, the live session recorded videos, and you can revisit and rewatch those video again if somehow you have missed any session due to some reason, because many of here are working, so they might miss some sessions because of work, because of some commitments they have in their life, right? For that purpose only we are giving here live recorded videos also, which will be uploaded in the link if you missed it. Okay. Any questions here in PD basics? So next is phase 2. Once after 2.5 months to 2.5 to 3 months, your PD basics are completed. That is what? Your digital basics, your CMOS basics, TICKLE basics, physical design, GVim commands and Unix commands, if these are completed, in 2.5 months, 2 to 2.5 months. Then you are in phase 2. So only if you are eligible, you need to give a test after PD basics are completed. Only if you pass the PDA basics, then only you will move to phase 2. Otherwise, you will not be eligible for phase 2, right? So in phase 2, that is PD advanced session, that will be between 3 to 4 months. So worst case, it is the 4 months, but it will be on an average between 3 to 4 months based upon the different scenarios. What is the main thing which will be helpful in this career of physical design? That is the EDA tool, the hands-on EDA tools which is used in industry, right? So the licensed tools are available here in this institute, right? The tool which we are using, the EDA tools which we are using here in this institute are from Synopsys as well as Cadence. So from Synopsys, we have Design Compiler, which is used for synthesis. We have ICC2, which is used for PD activities, physical design. Then we have Fusion Compiler. Then ICV for layouts, right? And Prime Time for STA and Star RC for RC extraction. Okay. From Cadence, we have Genus for synthesis, Innovus for PD, Tempus for STA, and PVS for physical verification. Clear, everyone? So these are all EDA tools which are available in Institute. So what is the class structure we are going to follow here in this institute for PD Advance? Once PD basics are completed for everyone, no matter you are working or non-working, or you are different year pass out or recent pass out, or you are in different domain also. Suppose you are in design verification, or you are in custom layout design team domain, right? But all these people will have one common batch of PD basics, because that subject, these subjects are common for every domain. You choose any domain, you have to learn the PD basics. But after you move into phase 2, your class structure will be different. Your batches will be divided as per your domain. Okay. So for PD advances, so in weekdays, we are having class from Monday to Thursday, and that will be completely lab sessions, right? Dedicated lab sessions will be given from Monday to Thursday. So what are the things we are going to do in that lab session? So you will get a project on which you are going to work on it on daily basis, right? According to the physical design flow, we are following it. Okay. So you will get the hands on licensed EDA tools, that is Design Compiler, ICC2, Prime Time. So based upon on which flow, on which stage you are in, with respect to that only tools will be used, right? Class will start at 10 a.m., sometimes 9 a.m. also. So it will be between 9 a.m. to 1 p.m. So somewhat 1 hour or here and there it might shift, or it might be in afternoon session, 2 p.m. to 5 p.m., or sometimes 1 p.m. to 4 p.m. also. So there will be two slots. One will be morning slot and the afternoons, based upon the trainer's availability, based upon the classroom availability, based upon the student preferences also. All these factors will be considered in deciding your class timing. It might be in morning session or it may be in afternoon session, right? For weekends, that is on Saturday and Sunday. So for weekends, there will be theory session. So it will be morning 10 a.m. or 9 a.m. to 12 p.m. or till 1 p.m. So it is the range between 9 a.m. to 1 p.m. you can take. Okay. Lab sessions will be from 2 p.m. to 5 p.m. Now, if you see, lab sessions are there in weekend also and weekdays also, right? But what is this lab session which is there in weekends? So this is not for the regular batch. So these lab sessions are only dedicated for the working people. Okay. So those who are working in weekdays, they don't have time to attend the lab sessions. So for them only, the lab sessions are arranged on the weekends. So for them, they need to attend theory session in morning and afternoon they have to attend lab session. Now, theory session is common for both the batches, whether it is a working or a non-working person. So theory session will be common for both the batches. Only difference is what? Lab session, right? So for the working people, your lab session will be conducted on Saturdays and Sunday during afternoon time, 2 p.m. to 5 p.m. Is it clear? Any question here regarding schedule, regarding timing? Any queries? All session, theory session will also get recorded and it will be uploaded in the link, VLSI Guru link, right? Any queries here regarding schedule from working side, non-working side, you can ask.
Sir, I have a doubt. Theory for weekdays, when 3 hours per day on an average. So weekends, we have only 3 plus 3, 6 hours. So how does that make difference? Is there any way of explaining the details for weekends and weekdays classes?
No, there is no difference. Trainer will be same person. Okay. You can say.
I mean, they have usually 3 to 4 12 hours and weekends. So you explain in detail for weekend classes or how?
There will be no difference. The trainer who is conducting your lab session in weekdays, the same trainer will be available on weekends also for the working people. So there will be no difference. You are going by time. It is not the time. For the offline people who are attending in weekdays, for them, the time given to them is more. Means why? Because if something is explained, so they will wait, the trainer will wait for them to perform also. That is why the more time is given for the offline non-working people. Whereas in the weekends, so people who are not attending offline, those are the e-learning batch or online people. So for them, lab sessions are conducted. Trainer will explain what is explained in a week in 2 sessions. Because it is a recorded session, it is a live session. Rest of the part, a student or the candidate can perform later on also. Understood? That is how it works.
Yeah.
So what about placement support and interview preparation? So once you have completed your course structure, that is the phase one, which is the PD basics, right? If you have covered the PD basics, you have attended all the sessions, you have completed all your assignments, right? You have passed the test of phase one and you move to phase two, right? In phase two, also same pattern we are going to follow. You have to attend all the sessions, you have to complete all your assignment, you have to complete and you have to pass the test. So if you have followed all this sequence, right, then comes your placement support and interview preparation, right? So once you are in the end of your course is going to end, right? During that time, we will start giving you some soft skill sessions also, which will help you in your interviews, which will help you to improve your communication, which will help you in different things like resume building, right? How you are going to deal with the questions which are asked from HR, right? What you should answer. Everything will be covered in soft skill session. right? So interview preparation sessions will also will be frequently given to you based upon the feedback given to you, right? There will be some mock interviews also. So in mock interviews, you will be getting some feedbacks like you haven't answered this correctly. You should have answered like this. So some feedbacks will be given. That feedbacks you can take it and you can improve yourself for the next mock interview round, which will be helpful in your real time interview. Clear everyone? Okay. So regular test will be definitely there. So those tests are like you. Those tests will be evaluated. The scores which are being given in those tests, those will be evaluated throughout your course. Based upon that, you will be getting opportunities also. So if you want to get a good opportunity, better opportunity, you should score well. You should be sincere in class without missing any session, right? That will build your credibility. Is it possible to have lab session in weekends by 4 p.m.? Because I have to manage college. Weekends by 4 p.m. See, the sessions will be strictly between 2 p.m. to last 5 p.m. So possibly depends on trainer also. If in weekends lab session can complete from 1 p.m. to 4 p.m., yes, that is also possible. That flexibility is also there based upon student preferences and trainers preferences. That 1 hour shift is flexible. Okay. But if sometimes if it is not possible, in that case also you have a recorded session. If you miss the last 1 hour part, so you can complete your work, whatever which is you are working as a professional, then you can come back to recorded session and you can re-watch it, right? That is also possible. So both options are there. Any questions here? So placement support and interview preparation will followed by these three stages. Test and assignment should be completed on time. All the mock interviews, right, which is given to you, you should definitely attend. You should not tell if someone gives you mock interview, right? It is scheduled for you. You should not tell that I am not well, I am not available, I am going to hometown, right? These reasons you should not give. That is a not good sign. Then you should attend each and every soft skill session also. Many people will give less importance to soft skill session. That is also not helping you. Okay. Don't miss any soft skill sessions also. So this is the complete placement process overview. So first step is completing your course and lab assignments and test, which is intermediately given to you, right? In PD basics as well as PD advanced. In step 2, clear all your internal test and mock interviews which is given to you. Step 3, you should complete your interview preparation sessions which is given to you. Step 4, appear for all the interviews with the hiring partners, right? So what does this mean? It means you will be provided with different opportunities, different interviews. Sometimes 2 interviews will be scheduled for you, right? Sometimes 3 interviews. So you should not tell that I will attend this one, I will not attend this one. You should attend all the interview opportunities which is given to you, right? That time you should not tell that I am not prepared well, I am not ready for it. It is given means you have to grab it. If you are not grabbing it, the next person will grab it. That is simple as such. So this is what we have discussed about the course structure, course timing, and what we are going to learn in those subjects, right? I mean the PD basics. Any questions here regarding timing, class timing, coursework, EDA tools, labs, timing? Any question you have in mind related to course structure?
Sir, for how many days will be the recorded session in the quarter?
Yes, it is a good question. So question here is that for how many days recorded sessions will be available? So it will be available throughout your coursework. So once recorded session is uploaded, till your course completes. That recorded video will be available in your link, right? You can rewatch n number of times. There is no time limit here, right? Any other question?
Sir, associated with this institute.
So there will be, I will explain that also regarding companies and all. In the end, I will explain that. I've taken paced learning. Will be its same schedules for class and lab session. So paced learning, I'm not sure about this paced learning. So paced learning means what you are saying? Is fast learning or what?
Yes, advanced learning, give a copy for that.
So paced learning means you won't have the PD basics. You won't have the phase 1.
Yeah.
So directly you can go to phase 2, right? And the PD advanced sessions will be given to you. That is the paced learning. So the theory session and lab session, the PD advanced session is the one which will be given to you as Google. So paced means the PD basics will be deducted. That is the paced. Okay. Any question? Any other question? Online, any other question? We don't have any idea about VLSI, even basics also. Yes, it will be taught from scratch only. The digital basics as well as CMOS basics. So even basics also means that you should ask yourself first that whether you are graduate in electronics or not. Definitely you have studied digital electronics and CMOS design or not. CMOS not there. So even though you haven't studied it, right? Still that will be taught here from the basics, from the number system we are going to start in digital electronics. Starting from number system, then Boolean expression, K map, right? Then combinational logic, then sequential logic. Everything will be covered. This is enough to grab opportunity by putting 2 or years of VLSI. I'm not getting your question.
Doing this after this course completion. Basic VLSI is exposure or having a 3 years of company.
So I assume that you are asking that this course is sufficient or not. So this course is very much sufficient, self-sufficient enough to get you a good opportunity, right? Cracking the interviews, it depends on you. As a fresher in physical design, no one in industry is expecting you with big terminologies and big explanation, right? They're expecting that you are okay with basics, you know how to work in tools, you know hands on. That is least expected from any fresher. If you have passed that, right, then you are selected in a company. Then with the time you will learn many things. Depends on project to project you are working, and that will improve your growth, right? That will improve your skills also. So no one learns in one day, no one learns in a year. It takes time. So does this course need more knowledge in analog electronics? No, it does not need deep or more knowledge in analog electronics, but you should know basics of CMOS, Pradeep. Now we have 3 years of experience in another domain. Which domain? After this course, could we grab by asking, I do have a experience in VLSI. So which domain? Please mention your domain also. 3 years in which domain? I have done BTech in information technology. not electronics. Can I get job opportunities in the VLSI domain? Okay. So Chari, so I would like to ask a question that as a part of your graduation coursework, have you studied digital electronics and CMOS or
Yes,
digital electronics?
actually, I have done a diploma in electronics. After that, I was changed the stream of information technology in BTech. So I have studied digital electronics and electronic device circuits and these things when I was in
Mm-hmm.
Polytechnic, and later I was changed to information technology. Currently, I'm working as an embedded tester,
Hmm.
but I'm not sure whether I will get the opportunity in real estate domain or not if I pursue this
See,
course.
there are what I see from your side that there are
Hmm.
many opportunities with respect to your profile also.
Okay.
The thing is, your background is diploma electronics as well as information technology. So
Yes.
PD is just not a physical design; it also needs automation also, right?
Okay. Yeah.
Combining the PD concept, if you are good in the programming also, so
Hmm.
you can for automation. For that, you need to be understanding the physical design first. Then only you can incorporate the learnings from physical design into automation part.
Okay.
So that is where I see from your side of profile.
Okay.
Okay. DevOps domain. See, DevOps domain has nothing to do with VLSI. Okay. So that 3 years of experience will not be considered. You will be treated as a fresher in VLSI industry. VLSI industry is completely different from what we are seeing in software industry. What is software industry? And what is VLSI industry? VLSI industry is not a software, it is a hardware designing, right? So lot of hardware designing means what? Electrical parameters as well as physical parameters, everything is considered, right? It is a chip designing, it is a hardware designing. So your experience as a DevOps, right, engineer will not be considered. You will be treated as a fresher here. What is the fees of the program? So that you can check with the manager. I did my graduation in ECA but working in software domain, hence planning to move to core. Yeah, this is fine. So if you have a EC graduation, electronics and communication graduation, and even if you have worked in computer science or software domain, you can move to core. That is absolutely fine. But thing is, no matter you have worked 3 years, 4 years, 5 years in software domain, that experience will not be in use. It will not be considered. You will be treated as fresher here. Fresher in VLSI industry, not in software industry. That is why I already explained your why, answer to your why, that software industry and VLSI industry is completely different. If I ask you to become next day IAS officer, you won't be appointed as a secretary immediately. You have to start from scratch, right, as an assistant DM or some assistant to some officer. You're not going to become a secretary in one day. Why? Because it is a different field. You are not experienced. Your software experience will be of no use in becoming a IAS officer. Understood the difference here? So VLSI industry and software industry is completely different. If you want to bring your software experience in use, so I see that you can go into programming, you can go into automation, which is used for tool development. Yes, there I see that your experience can be of some use, but not as a designer. If you want to become a designer, then your experience is of no use. Clear? So there you won't be fresher. Suppose if you want to go into tool development, where programming, the language, the algorithms, right? These knowledge has to be there. Right? There, of course, your experience might be in use, but not as a hardware designer. Your experience is of no use. It can be helpful, it can be a skill, but not directly used. Like we say that TCL language is a scripting language, which is a indirect skill which will be helping in your main task, but it is not the main skill. Now it is not a core skill, right? I have 4 years of career gap between completed in Triple E. Do I have any chance of getting placed? How is your institute helping such students, and what makes you differ from other institution? Okay, so the gap will not affect your the opportunities which is given to you. It is absolutely fine if you have gap. But thing is, you should tell what you are doing in that gap, right? That is must. So gap is fine. Yes, there is a very high chance of getting placed. How is institute help? So institute, like I said, I have already discussed the course structure here, course timing, the video recordings, materials, the EDA tools, whatever things are required in industry to make you industry ready, that is given in this institute. I don't know about the other institute, right? Because I am a trainer here, I don't know. I haven't studied in those institute. I haven't taught in those institute. So I'm not the better person to comment the comparative thing on institute. You can check with the manager of the institute regarding the comparison with the other institute. But what is given here, I can tell you for sure. Could you provide more details about course material? Yes, I will explain, Shruti. How will I get placed, fresher or experience? So it depends, right, on your profile. So you are a EC and you have, so you will be placed as a fresher only, right? You'll be placed as a fresher. I will tell you about the companies and those things in the end. Don't worry on that. See, most of my friends had experience in software and they moved to VLSI. It is completely fine. You can have experience in software and then move to VLSI with their experience by learning VLSI course, right? But that experience will not be considered. Your computer science experience, your IT experience. So if they have moved in VLSI also, that is not designing part. So as a hardware designer, you will, that experience will be of no use. I already told you. Being 2021 passed out 2021 triple E with 4 years of gap, how will I get placed as a fresher? I already told, right? You will be placed as a fresher, not as experience. I have done BTech in EC 2016. Because COVID postponed exam, I am starting a 2020 so railway signal engineer for 5 years. Railway signal engineer. See, this will also not help you, right? What I can see, the railway signal engineer, I'm not sure whether you are doing electrical designing, right? In some cases, PCB designers get somewhat advantage sometimes. If you go in global foundries, the manufacturing companies, they get some advantage because of PCB knowledge, that the process knowledge they know. That's where they get some advantage. But signal engineer, I don't think. Most of the railway signal systems, I don't know, nowadays lot of automation is there, but the most of the railway signaling is a mechanical plus electrical parts. So there is no nanotech here. What we are discussing here in VLSI is all about nanotechnology, the thing which you cannot see by your naked eye. We are talking about that kind of designing. Okay, so I'll take uh, some questions in the end also. Let us continue with what we were discussing. So tool access, Suresh, will be there throughout your course. Tool access will be there. Additional, after even completion of course, 15 to 20 days extra time will be given for your practice, for your revision, even after completion of your course. So many of you are here new. They don't know. You don't know about what VLSI, what we are doing in VLSI. So if I ask you what is VLSI, what is your answer? Why you want to come into VLSI industry? What you know about VLSI industry? Anyone? What is your name? Your name? No, sit down, sit. Hari. What is VLSI?
Stand for
Not stands for it. Not tell stands. What is what you understand from VLSI?
from backend from starting scratch from designing to the fabrication, final fabrication.
What is VLSI from online? Anyone from online? So you are here in this demo session. You should be very clear with this. If someone asks you what is VLSI, immediately your answer should come. If you are going to choose VLSI as a career, at least that point you should be very clear.
like it stands for, if there are hundreds of millions of gates, this is very large scale. I mean, it depends on, there are medium scale, small scale, and this is very large scale. So very large scale, it says like millions of gates integrated in each chip. That's the basic. That's why the name came VLSI. So the process starts with writing a developer identify the chip design. Then only the entire process is a VLSI design.
So the full form says what? Very large scale integration, right? That is correct only. The full form is not sufficient enough to explain VLSI. So very large scale integration of what?
Because of gate.
Gates or yes, transistors, right? Good. So it is a integration of transistors. So very large scale. What is this amount? What is this large scale?
Millions of transistors came together.
Millions or billions?
Now it's billion.
Billions.
You can check, right? So yes, there are large scale integration, there is medium scale integration, there is small scale integration, right? Now we have ultra very large scale integration also, ultra scale integration also. So the count of transistors are in billions. Okay. So what does this mean? Integrating all these logics, all these transistors in one single piece of chip, right? So that process of integrating all these transistors and building the chip is nothing but called as VLSI. So whatever we are doing, right, the end product is chip only. The process is to integrate these all transistors into one chip. Integrating means what? Having some integrated circuit. Now what is integrated circuit? IC, which we said. What is integrated circuit?
Logic design based on the gates and
Integrated circuit means combination of circuits. If you see a building is an integration of rooms, right? Halls, rooms. So you take one room, integrate it, you will get a building. So integration of circuit means integration of multiple circuit. VLSI means integration of all the transistors. Now these all transistors are used to build one circuit. Like that, multiple circuits will be there on chip, right? That is how complete. So there are many process, many stages in this complete to get the end product, right? So the chip fabrication or chip design is very complex and very complicated process in nature. It is not a straight single flow. You just do a one push button. It's not like that, right? So what it involves? It involves manufacturing of semiconductor chips in fabrication plant, right? We'll discuss what happens there also. Chip designing, the first part comes is before sending it to manufacturing plant, you should also design it first, right? The designing of architecture, designing of logic, and layout of integrated circuit, right? So whatever design you're getting, right? So it should be properly designed using logics, gates. Then only you are going to send it to manufacturing lab. Now, can you tell me what is the size of transistor? What is the size?
Nanometer only.
Size. I'm not asking unit. I'm asking size. What is anyone from online? What is the size? Value. What is the value?
You can tell what is the last thing.
What is the size of transistor? You have heard this word feature size. You will say sometimes feature size. What is that? What is the number?
Then
What is that?
gate size.
Number.
Sir, at present, a few companies are working on 2 nanometers.
Sorry, can you repeat?
So at present, few companies are working on 2 nanometers, but at the latest version is 4 nanometer.
Yes, correct. So this is some example, right? 2 nanometer. We say 4 nanometer. We say 7 nanometer, 10 nanometer, 3 nanometer, right? What are these? These are called as feature size. These are called as transistor size. Now, when we say transistor size, which part or which size, what dimension it is explaining when we say feature size? When you say 2 nanometer, 3 nanometer, so can you explain, or 10 nanometer, or let's say 90 nanometer also, right? So this dimension of 90 nanometer in the transistor, it is for which part? Means I mean the dimension is explaining for which part of transistor? Anyone?
The gate length.
What is gate length?
Transistor has a gate length. This I know. Gate has dimensions.
First of all, transistor is a two-dimensional or a three-dimensional? Three-dimensional, right? Now, if you say gate length, can you tell me which part length, which side? How I can understand which length? It is a three-dimensional. Which dimension you are referring to? So it is a channel length, right? It is called as channel, not gate length, right? So that channel length is nothing but what we say technology node, what we say feature size is nothing but channel length of a transistor, right? Basically, what transistor is used in VLSI industry? It is CMOS, right? What is CMOS? It is a combination. It is a combination of complementing two MOSFETs. One is PMOS network, one is NMOS network. Right? If you combine these complementing MOSFETs, you will get a CMOS. Is it clear? Now, what is the feature size? If I say, what is the technology node? It is the channel length of that transistor. And it is what size? 90 nanometer we say 45 nanometer, right? Now how small is this number? Can you explain? What is the size of your hair, one hair strand? What is the size of your one hair strand? What is the size of your, what is the now you say that you have been through the COVID stage, right? What is the size of COVID virus, coronavirus? Anyone? What is the size of corona? Can you see coronavirus from your naked eye? So what is the size of coronavirus? Anyone from online who has seen coronavirus? You can tell me what is the size. Micrometer? What my how much? Micrometer also fine, but you can tell me right value.
Right? Actual
Value, that's what. Conversion you can do anything, right? 120 nanometer, right? 120, so 120 is the different variant actually. So it is between 120 to 200 nanometer. So nowadays we are having different variants also in COVID. So different variant has different sizes. So it is ranging between something around 120 to 130 to 200 nanometer, right? And at what scale right now industry is working in? It is working in 2 nanometer scale, 3 nanometer scale. So it is even less than what coronavirus. 1 point. And the working, it is R&D technically now. It is not been market. Intel already failed in that. So it is what, so there are different what technology nodes. So you can just understand by this that it is 100 times less, more than 100 times smaller than even COVID virus, coronavirus. So that on that scale, your transistors are there, and on that scale, your feature size is there. Means using those transistor which is very small, right? Even less than coronavirus, you need to use these transistor to design the circuits, and using these circuits you are going to design the integrated circuits, and using these integrated circuits you are going to design what? System, right? The complete system is developed by using these nanotech transistors. Understood? So how lot of things now becomes very complex here. How things will get connected, how they will get routed, how device will behave to the resistance, how device will behave to the capacitance, right? Everything has to be taken care or not. So you know there is a term called as static charge, right? In childhood days, you might have used pencil and you have rubbed your hair and you stick to paper. What happens? Those that paper sticks to pencil or not? That is static charge. Yes. So by that small amount of static charge, that paper is getting attracted to your pencil because it is now having a static charge accumulated at the pencil surface. Now you can just understand the chip is at nanoscale at a very small number, right? So how much dedicatedly you should work on that chip designing, that it should be static prone. It should not get affected from any external static charges, right? See, moment you touch your laptop, right? If it is very sensitive, the laptop will again shut down. If it is not resistance to the static charge, because your fingers are also always carrying some static charge, you rub it or not, it is having some minute amount. At that nanoscale you touch the design, your design is done, completed, burned, right? So your design should be very robust in nature, such that I'm just giving one example. There are n number of external factors which can destroy your design immediately, right? So you should not every time going to send your chip design to the manufacturing lab and then they will tell you that your design is failed. That is very costly, right? Every time you're sending and manufacturing process is going on, it is a costly process. That is the reason we have separate design cycle before sending it to manufacturing labs. Now, what is this manufacturing lab called as? It is called as foundries. So these foundries which is available here, right, in this world, right? Those are TSMC, UMC, Global Foundries, and CIMIC, right? So Intel and Samsung is also there, right? So major 70 to 73% of market share contribution is from TSMC, Taiwan Semiconductor Manufacturing Chip Facility, right? Now, what is, so these are called as fabless based company. I mean, sorry, these are fab based company, means which has a fabrication lab setup, right? Their job is not to design the chip, it is purely manufacturing facility. Now, what is the chip designing doing here, right? They are the fabless companies like Qualcomm, AMD, Broadcom, Nvidia, and so on. So these are the fabless based companies. They are not fabricating anything. They're designing the robust chip which is going to be sent to a fab company, fabrication, right? For fabrication process. IDM is also a company, right? You can say IDM is there, IBM is there. So two different things. Okay. So what are the key tools which is used in chip fabrication? Or first we'll say what are the key tools which is used in chip designing, right? So ICC2, Design Compiler, Innovus, and Fusion Compiler. These tools are called as electronic design automation tools. Now you are working in what scale? A nano scale. You cannot use pen and paper to draw the circuit, right? So you need some electronic design automation tool such that you can design your integrated circuit in nano scale. That is the advantage of what? EDA. Major advantage of any EDA tool, whether it is from Synopsys, whether it is from Cadence. So what is the first most major advantage here? Is you can draw, you can design your circuits in nanoscale, right? So key tools which is used in chip fabrication is caliber, T-cent, and PVS. So these are mostly related to the physical verification or the layout based tools. So it is going to verify your physical design actually, right? Whether everything is fine or not, whether it is ready for manufacturing or not. See, once you have designed something, whether you are immediately going to send it to manufacturing, you need to test also, right? Suppose you have designed a car, whether you are going to send your design to manufacturing immediately, first you need to validate that design or not, whether it will work or not, right? Suppose I want to make a car with one wheel, right? So you have designed also, you have designed, right? I will just so I'll design one car, right? So let's say I'll design something like this. I have designed a car with one wheel, right? Now I'll send it to manufacturing. So manufacturing people will manufacture this, but whether it will work, hmm? It won't work. But before sending to manufacture, if I test this, right? How I can test whether this is possible with respect to the laws of physics, right? Whether this is possible with respect to laws of physics. Then I met Rohit Shetty, right? Who is a film creator, movie creator, right? Now he said that we will design one scene where two cars are there, right? And hero will stand like this with one leg here and one leg here, and both car will drive in opposite direction. And this does not follow laws of physics. In reality, this won't be able to be realized, right? You cannot realize this in reality. But okay, this is a fictional thing, fictional movie, so it is fine for entertainment. So here it does not work like this. You need to go by laws of concepts which we are discussing here, right? It will not work in manufacturing until you are following the concepts. So what does laws of physics says? There is something called as balance, something called as equilibrium, something called as gravity, right? Every something called as rotational per minute, right? Something called as weight distribution, something called as strength, material strength also. Now I'll use plastic and make this car. It will not work. So everything matters here, right? So all those things has to be validated or not. Okay, body strength, I've used this material. I've used four wheels for balance. I've used this much of RPM for this wheel to get what? A fast car. So everything you have to validate in design level only before sending it to manufacturing. Understood? This will save time and money. That is the reason.
So when you do physical verification, let's say if the physical verification tool fails to capture a DRC, okay, now they send it to Fab, and now Fab sees that violation, and design team is okay with the violation. Let's say a small spacing violation.
Design team have no decision.
Like NVIDIA, let's say they send a chip to TSMC, and there is a DRC, physical DRC, and they are okay with that NVIDIA. Now, TSMC will probably do manufacture or not?
You are telling that design is there and PB people have not given any DRC.
Yeah, it failed to capture it.
It's not possible, right? How they will fail to capture? How you
Let's say when
came to that conclusion that they have failed?
same program. I mean, let's say even if they're okay with that.
First of all, you should understand how any tool is capturing, right? Tool is just a medium. Tool is not doing the work. What is doing the work? Based upon how you are able to talk, how you are able to walk. No, how you are able to walk, how you are able to talk. That is the medium. You understand what I am trying to say? Based upon that is also medium. So if I don't give you any inputs, right? Whether you whatever you are saying, tongue, brain signal, and these things will work. If you don't eat food, if you don't take the energy, whether your medium will work, then so important is what? Right input. You eat mud and leaf and you expect that your medium will work. It will work. So you have to eat right inputs. You have to take right inputs. If you are taking the right inputs in your PV, definitely it doesn't matter which tool you are working in. So it will give the right outputs. The tool development core is basically same in Cadence as well as Synopsys. Only thing what makes it different, it is the features which they give, which they provide, the automation part which they provide. But the catching of DRC is purely based on the inputs which is given to it. And that input is independent of any EDA tool. And from where we are getting that input? We are getting it from fabrication companies, foundries. Those are called as technology files. So they will give you set of rules, set of constraints, physical constraints.
The textile that is helpful in running the flow. When you
Not helpful. It is the rules, it is the constraints if your design follows or not.
But when you do get a presentation, before takeout, you just the caliber, ICV, and this decks, right? Unset is there. So who will code that?
What?
Like textile is for your design implementation. But for the physical verification, you take that layout and the voices files. Then use the calendar, the ICV, or whatever the physical verification role you do. Then we check that. I mean, the rules are different textile and the rules which are validating before doing table. So there are two different things, right?
The rules are required or not?
Rules are there.
If it does not follow rules, no, I am trying to understand how it will not catch DRC. You said DRC did not catch, right? In what sense, in what case, how it will fail to catch DRC?
And there's will still have
That is the tool issue, right? So that is the reason tool will have every 3 months, 1 month, they will be releasing new versions. So if some functional code in tool development is not that much is good enough to catch some DRC, that is the tool thing. But basically rules is constant for irrespective of which tool you are using, right? Rule file is common coming from the TSMC. It is given to the every person. That is independent of tool. So it is a tool problem. Understood? If tool is not able to catch, nothing, neither TSMC will take credibility or they will not take the responsibility or the design team.
just
No, not manufacturing back. So the person who is from the synopsis or the cadence, so they have to work on it, right? So then, what is your question?
So when they see ERC from their side, they will send it back to fix this.
From which side? From which side?
Okay,
They will not see DRC. They will not check DRCs.
then just
They will manufacture. But before manufacturing, you will also. So after PV, your design does not directly goes to the manufacturing. There is one more stage called as post-silicon validation. So definitely there, before manufacturing only, there you will come to know that whether your design is having some issue or not. So again, it will be sent back. It will not go to manufacturing unless and until you have a zero DRC. What is the reason? Why manufacturing plants will work means why they will design with your DRC thing. Then why it is called as design rule check, right? Why we should check those rules? If rules are not followed, why we should fabricate, right? Rules are given to followed. If it is not followed, no fabrication lab is going to manufacturing it. It will not manufacture it. So rules has to be followed. That is why it is given to. If not followed means you have to work on it. It may be tool problem, it may be file problem, it may be design problem, but that has to be fixed. It's not like okay, we will the design will not work. Design will lead to failure. Out of 100 chips, all 90 chips, 98 chips will be failure. Then what is the use? Understood?
so fab company will not manufacture.
Fab company will not manufacture or manufacture. What you are telling, I'm not getting.
It's a company will take off from it.
Fabrication lab is for manufacturing only. What I said.
If there is
They will not. They will not accept your design.
He says that there is a vital topic in the design rules, right? Will the manufacturing companies like TSMC, AMC,
They will not accept.
the people?
They will not accept. That's what I'm telling.
That's the good thing is asking.
I'm also telling that they will not accept from starting. And I'm telling reason also, right? You're getting. So it is very important that your design is passing all the sign-off checks. It is not only PV check, there will be power related check. There will be timing related checks also. So it has to meet all the sign-off constraints. Then only we can say that the design is okay for fabrication. Okay. So what are the key tools we have discussed? The process which is used in fabrication. I think you have studied in graduation, almost everyone. What is the process? The process means process of fabrication. So first is photolithography, then etching, then doping and deposition. You might have studied and you have written in exams also. Right? You need to just revise, and it will also covered in PD basics. What is the fabrication steps? Okay. Then in chip designing, we have RTL, coding, synthesis, physical design, and verification. The first step is nothing but the RTL code. What is RTL code?
Yes,
Verilog code. You should not tell Verilog code if they ask RTL.
level, optimized gate level codes.
I ask RTL means you're telling full forms. Yes, it is correct. What you are selling as a full form, it is correct. But it is nothing but a circuit design only, in short. If you are, yes, logical circuit design, you can tell, using logics, right? Basically, RTL is a circuit design, but we are saying code also. Using what code? Using a software code. Is it? It is a hardware code, right? It is called as hardware description language, HDL language. It cannot be specifically Verilog code. It can be VHDL code also. It can be if there are multiple HDL languages. Any languages can be used to describe what your hardware. So it is basically what a circuit design, right? So after that, you need to do synthesis. Whether your code is having information about logics. So how many of you have gone through like Verilog? Have you studied Verilog, VHDL in future? So those who have done maybe MTech in VLSI, they might have studied, or those who have worked in VLSI also, they might have seen sometime what is Verilog, or in some graduation also. Nowadays they are having Verilog subject, not subject. I will say lab sessions are there. You have gone through Verilog or hearing it for first time? Okay, you. But you have heard this term Verilog? Means studied in graduation? Okay, you heard. So it is a hardware description language, right? So Verilog will have four models actually. Say one is behavioral model, gate level model, right? And data flow model, and what? And transistor level model. So there are four models here, right? In any one of these model, you can explain or you can describe your circuit. So all these models have their own advantages. If you write code in behavioral model, right? You don't have to describe in terms of logic. It can be described with using high level languages. Like what? What we say, what is high level language? Like you have studied C++, right? So we say that C++ is a high level language. What does this mean?
easier understandable by the compiler.
If it is easy, then why we are telling high level language? It is a low level language. Anyone can understand. High level language is not for you. High level language is for machine, right? It is not machine friendly language. What is comfortable language for machine? Binary language. The easiest language machine understand is ones and zeros. So high level language is for machine, not for you. Okay. So what are those? If else statement, conditional statement, case statements. All these are high level languages. If you are describing your circuit in terms of high level language, then it is a behavioral model. You are describing the behavior of a circuit in terms of high level language. That is behavioral model. So if you write that, there is no logics in that code. You are not telling that this is the AND gate, OR gate, NOR gate, right? For an example, I'll give you. If you take one mux, right? If I take this mux, this is S. So what is this mux? It is a 2x1 mux, right? Can you explain this without using logic? Can you write a code in C language for mux? So you have to write high level language, conditional statement. If what is the statement? What is the condition? If S equals or based on syntax you are following, right?
If
Is
S
0,
equals to 0, then I naught Y
then
will be output will be I naught.
right. Then Y is I naught, else Y is I1, right? If S is 0, then your Y is I naught, else Y equals I1. Is it clear? Whether you find any logic, here? No, right? There is no logic defined. So you're just defining what? Behavior based on inputs and outputs. That is called as behavioral model. So same thing you can write in Verilog also. So in Verilog, the syntax is usually starts from module name and ends with end module, right? In module name, you can give the module name, but before that, you have to define what are your inputs, what are your outputs, followed by the module name, and then you can start, right? Then you can write these. So that is behavioral. Now, what is gate level? So in gate level, you have to write the Verilog code in terms of logical gates. Now, it's the same mux if I ask you, how many logical gates are required to design 2x1 mux? What is your answer?
It's not I, S and I1 is equal to Y.
How many logical gates are required?
It's a AND gate, OR gate plus AND gate, 4 gates.
Okay. Yes, others? Do you have a different answer or any other answer? This is a digital concept, right? This is nothing to do with VLSI concept, nothing to do with physical design also, right? That is where we say that physical design, before physical design, you should learn basics first, right? That is where it will be helpful in understanding physical design in faster pace. If you're brushing up with your graduation basics, right? Digital basics or CMOS basics. So how many logical gates? So 2 and 1 OR and 1 inverter. right? So total number of logical gates required are 4. So this is the selection line, right, which is altering between the two inputs, I0 and I1, and this is 1. This is nothing but 2 cross 1 box. Yes, so 4 number of logical gates are required. Now the same Verilog code you can write in gate level language also. How? So you can define each logics and its connection. Now if you see, these are, how many ands are there? 2 and. Let's say this is and 1, and 2, or 1, and this is inverter. So you can write and 1, right? What is the output? Let's say this is W1, W2. So output is, so we will give some name also. L1, W1, comma. What are the inputs? I0 and S0 bar. I0 and S0 bar. Similarly, and 2. L2, W2 is the output. Then S and I1 and S. Like that you have to write for inverter and OR also. If you write all these connections with the logical information, with the logical gate information, that is what you are defining your logical design. This kind of design is called as logic design. Understood? Clear? Now, so what we were saying, that what we were discussing actually, synthesis, right? So what happens in synthesis? Whether we have any logical information in our design, if we follow gate level design, yes, logical information is there in that model. But whether it is technology dependent, whether that logic design is technology dependent or independent, just now what we have discussed. So another question which is linked to this discussion is what? Whether this logic design is technology dependent or independent. You understood what is technology? I've discussed half an hour before, right?
Let's say if you have circuit that is available in that technology. Let's say if you have mux that is available in that technology, or you need to come from and this kind of logic that generate gates.
Technology, we don't have gate information. What information we have? Information about, in technology we are giving information about just now, means half an hour before I've told, right? You are catching what I'm telling. Technology, does it have a gate information?
During mapping, it will take information.
Technology foundry will not tell you gate information.
Technology mapping will be there, right?
What I have told, what is VLSI? First thing what I asked, it is a integration of transistor. Where it is manufactured? In fabrication lab. What it is manufacturing? Integration of all transistor. It does not see things that this is and this is R. What it is fabricating? Transistors. Right? What is the process? Photolithography, etching, right? How, what it is fabricating? Not logical gates. Transistors. How many transistors? Billions of transistors. Those are connected, integrated to get what? Circuits, system. Understood? So technology does not have any gate. So what information it has? It has feature size of a device, right? That is what? Channel length. With respect to channel length, all the different sizing of the transistor and layers are defined. So device is nothing but a combination of layers or not. Device means what? Transistor. Transistor device. It is a combination of layers or not? technology has the information of layer information, right? Not transistor information. What I am telling, that any transistor is a combination of what? Layers. What layers? Transistor is made up of what layers? What are those?
Interconnectivity within a transistor.
What are those? What are those layers? Yes, you said base layers. I'll take it. Base layers. What are those base layers? Transistors. See, there are many base layers. Right? It is a combination of base layers. You are saying it is. There are some layers. Will not go by base or what not base. Right? Just say that it is a combination of layers. What layers? Substrate. Right? We yes, Nikhil, correct. It is a N well means what? There is a N-well diffusion layer, there is a P diffusion layer, there is a substrate, then we have a poly, right? Transistor is a combination of layer. So what technology has? Technology is giving us information about layers. It can be in any layers. It can be interconnects also. It can be device layers also. So, but these all information about layers is dependent on what factor? Feature size. That is what? Channel length. Whether your device is in 3 nanometer, 10 nanometer, 180 nanometer, right? Based upon that only, all the layer information, layer rules are defined in where technology file, right? So tech is dependent on feature size. No, it is not exactly 3 nanometer. So there will be overshoot and overlaps also. That will be completely discussed in CMOS sessions. So it is not exact 3 nanometer. Practically, you will never get exact 3 nanometer. So you will learn that in CMOS more. So in technology, the feature size, right? It is dependent on feature size. Now, what information it has? It has layer information. What layer information? Device layers, right? As well as interconnects. Interconnect layers. Interconnects for what? Connecting the devices also you need some layers or not, right? So device layers means what? Substrate, N-well, P plus or N plus diffusion layer, right? P diffusion layer, N diffusion layer, right? Poly, contact, right? All these are part of device layers, right? Then what are interconnect layers? Now you have designed now you have fabricated what? A device. Let's say this is NMOS, right? This is PRN, this is PRN. P substrate or N substrate for NMOS? Right, we have to take P substrate, and this is yes contact. See, contact means you are not like you have to use some material, right, to connect two different layers. If we talk about layers, I have already told it is a three-dimensional, it is not two-dimensional. So if you want to connect one layer, one plane to the other plane, you have to use some medium. It means there is some material which is connecting these two layers. That is nothing but called as contact layer, CO layer. N plus diffusion layer. So this is nothing but roughly I am drawing this. So silicon dioxide and poly. So this is what poly, right? Let's say this is your device. Now you have fabricated the device. It is getting fabricated. It has to be connected to some other device also. If you are working on some circuit design, let's say a single inverter. A single inverter requires one NMOS and one PMOS. How this will be connected? Right? If you draw like this CMOS structure, one PMOS connected to NMOS. Now how you can connect this? So you can see these two inputs are common and you are taking output from the which side? Drain or source? Source.
Drain for PMOS.
Drain for PMOS. Which one is drain and which one is source? Starting from 1, 2, 3, 4. This is PMOS, this is NMOS.
For PMOS, one is drain, two is source.
Okay. For here?
3 is source, 4 is drain.
Okay. Is it correct? That is why we are also giving CMOS basics, so that you can connect with the basics also before going towards PD advanced session. Right? So this is not correct actually. Right? So for NMOS, this will be drain and this will be source. No need to memorize this. It is completely purely based upon concept. Why? For NMOS, how your current will flow from drain to source. How your electrons are moving in NMOS device from source to drain. It means what? Current is flowing from higher potential to lower potential. If you see the NMOS MOSFET circuit, right, the higher potential is always connected to the VDD side. That is we say that VDS. Why we say VDS? Because current is flowing from VD minus VS, means the potential is VD minus VS, means current is flowing from higher potential to lower potential, right? Whereas in PMOS, it is reverse of NMOS, what we have discussed, right? So it is flowing from where? No, here also it is, you have told wrong. So here also it is source and it is drain. Clear? Clear, everyone? So these all things, the working of MOSFET, the regions of MOSFET, and how electrons flows, how current flows, why from source to drain, why only drain to source, why not like this, everything will be covered in CMOS revision or CMOS basics. Okay, now we will not go into that, right? So if you see here, the connection is like the drain and drain are short here, right? So what you can do, so you can get one more, so you have one PMOS and one NMOS, right? Now you have seen that drain and drain, the two drains are common, right? So this is what, nothing but a layout. You can see, let's say this is drain and this is drain, this is source, this is source. So two drains are common, you can collect output from here, right? Now if you see source, I mean the gate, two gates are common or not? So this is nothing but poly. You can see it is a common to both the logics, I mean both the devices, BMOS and NMOS, right? From where you can collect inputs, but this is poly. Can you give input to poly directly? Can we give inputs to poly directly? Poly is what? Base layer, right? Which is defined in technology. Can you connect? No. That is where I am saying, don't worry about that, why I am not getting it. See, you will understand this in CMOS basics, right? Usually we can't give input to poly. Why? Because poly is highly resistive in nature. So the resistivity is very high. So we cannot give inputs to poly directly. You have to give a metal patch on this poly. You have to connect using a via. What is via? Via is used, it is kind of contact. We will not say contact, but it is a kind of contact which helps us to connect two different layers, not metal layers, two different layers. So here in this case, this via is poly to metal layer. So poly is the bottom layer and metal is the on top of it. So it is connecting these two layers. Now inputs will be given to this metal layer. Similarly, how these two drains are connected of two devices using what? Metal layers, right? Now these two connections are on top of what? These devices are not. So how these connections are established? If you see, this is connected with VDD, source side, and its source side is connected to ground, right? Now where is VDD and VSS? So you can give one VDD line, power line. You can give one source line, I mean ground, right? This is VSS, this is VDD. So but there is no connection between VDD to the device, right? Your device is not getting power. How it will get power? You have to give one connection using what? Again, interconnect, metal layer. So you have to drop contacts, right? Again you have to connect. So this is what source side is connected to VSS. Drain side is, I mean, this is also source side of PMOS is also connected to what? Supply, VDD. Understood? So the device having some combination of layers, then device has to be connected with another device or not to get one circuit. So this is what? Inverter CMOS layout, right? It is a layout. A layout means what? Layout means top view of your device. If you look, if the device is a three-dimensional, if you look it from top, it will look like this. So layout is nothing but a top view of any device, right? Is it clear what I am telling here? What I am trying to make you understand, that technology has what? Technology has what? Layer information, and this is dependent on what? Channel length of device. That is called as what? Feature size, right? What you say, 180 nanometer or 90 nanometer. Now based on this, all these are layer rules are defined, right? What are all those layers? Just now we have seen it is base layer and metal layers, right? Now what are all those rules which are going to be defined here? It is minimum spacing, minimum width, what is the pitch of metal layer, right? So all, there are many rules with respect to some physical constraint, right? Appearance based definition is also given. So these are not strict, these are not rules, these are just tool specific. If appearance is like metals, I will define it as blue. So in tool, it will look like blue color pattern, right? So color pattern is also defined in what? Technology file on. But these are not rules. These are not hard constraint. No matter what color is there, what pattern, it does not affect your design. It does not affect your end design. Understood? Important is what? These rules. What is the minimum spacing between two metal layers? Right? How much minimum? Who will give you this rule? Foundry will give. You cannot take any number, right? If minimum spacing is 0.12 microns, right? But if you have taken 0.06, can you send it to foundry? Can you send it to foundry? Absolutely not. Why? What is the reason? That is, this is a DRC violation. What? Why you cannot send it to foundry? What is that limitation? So foundry is not like a software designing, not like some hardware designing also, not, it is not a tool based also, it is not a of course the automation is computerized, but foundry is 80 to 90% is mechanical machines. It is 80 to 90% what? Mechanical machines. What we are doing completely based on CAD based tools, EDA tools, right? There you can have a lot of flexibility because you can change code, you can change values, you can do something, change the files, change the inputs. But when it comes to 80 to 90% of mechanical operation, you don't have that much of scope and flexibility. If I say there is a 90 nanometer of foundry, right? So it is dedicated to develop those chips only, which is designed on 90 nanometer scale. Recently, you have heard in Ahmedabad, IBM, right? Sorry, not IBM. What is that company? IBM only, right? Or there is different company.
What have new foundry?
Ah. Tata is also there. There is one more. They have completed one phase in this last year, right? IBM only. Okay. So if you see, they have set up a fabrication lab, I think 180 nanometer, 90 to 180 nanometer, something like this. So big number only, not in the commercial scale, right? So they are designing, they have set up the fab lab with some big 180 nanometer or something like 90 nanometer, right? I think 180 only, I have read somewhere. Okay, you can check, cross check once. So once that fab lab is set up on 180 nanometer, can it fabricate a chip design with 90 nanometer? Of course not. Why? The machine setup is very costly. It takes crores and crores of money, right? Millions and millions of dollars. So once it is set up, again you cannot change the setup for 90 nanometer, for 10 nanometer. It is not flexibility, right? It is completely machine-based operation. Of course, those machines are controlled by the computers only, programs only. That is where automation is useful. But machine is working, the dimensions and the size, everything, the environment is set to some value for the fixed value. If that has to be changed, that process has to be changed, that is a very costly thing. Is it clear? It takes lot of resources, not manpower, not man resources. The material resources, the machinery resources are very costly. And that also you cannot take any quality of materials, any quality of machine. That is a very high grade material, and even the water facility, the water which is used while fabrication is also must be of high grade. We cannot use any river water, the because the water is also consisting of what? Charges, some ions, right? It has some metals also, heavy metals also in water. Those kind of what, sodium also is there, that will be getting reacted while fabrication. So the kind of water which is used also different, so that is a very costly process. They have clean rooms also. So when you enter, any engineer enter, any control engineer, we'll call it as engineer, not a design engineer. So they are basically a control engineer, right? So these people will be wearing a complete suit or jacket, right? So that any dust particle or hair particle from your dust or something from your cloth, from your body, it does not fall in that facility, right? And the light is also controlled. So there is a term called as luminosity, right? If you see in cricket matches, when there is a rainy season, so umpire will come with a gadget and they will check what? Luminosity, whether light is sufficient or not to continue the game. Similar way, that luminosity is controlled in that room also. You cannot have tube lights or bright light in that room. So certain kind of wavelength is also controlled in that room. That much of complexity is there in fabrication. Small amount of variation in any of these parameter will reduce your yield in the production of chips. Clear? So it all very much important. That is why they will give us technology rules, right? Foundry has some very strict limitation. They will tell the designer that if you are designing in 180 nanometer, you have to follow these rules. If it is missed, if anyone is missed, we cannot do that. We are not capable of, because our machines are not capable of. Okay. Okay, let us move to next. So this is what we were discussing. So this is what I was asking, whether the logic design which we have written, right, is it a technology dependent or independent? So it is, of course, what? Now you can answer this. What was the question which lead us to this discussion, right? That the logic design whether it is technology dependent or independent. Can you answer now? Yes, technology dependent. Of course, it is a independent or not. Whether in code, are you defining these logical gates having transistors? Anywhere transistor definition is defined while writing the Verilog code or the hardware description language? Not at all. You are for which? PD demo? PD physical design demo session? I don't. You can check ground floor in reception. No one is there. Okay, you can. You have a number. Is office you can call. So yes, the logic design is what? Independent of technology, right? Why we are saying there is no transistor information here, right? There is no feature size information here. There is no spacing or rule violation. Nothing we are discussing means no physical constraint is taken care while designing RTL. So the RTL designer does not care about any physical attributes, right? You tell spacing, manufacturing, fab, this, that, everything. It's not their headache, right? Their headache is what? Whether the design is functionally correct or not. That's all. Their job is done. And who will verify that? Whether the design is functionally correct or not. Functional coverage is there or not. Yes, the functional coverage team is there. That is called a design verification, right? After the logic design, there is next stage called as design verification team. So, DV people, yes, the RTL verification, that is called as RTL design verification. What they will do, they will pick this logical design, they'll create a DUT, that is called as design under test. Under that, they will write some protocols or the verification environment they will create, which has monitors, core board, right? Like that, they will create an environment where once a design is inserted into that complete system, it will be verified based on, yes, based on what? Test benches or test cases, we say. So it will be difficult for the new person to understand all these terminologies. I'll make it simple. Suppose there is one car. Now car is designed and you have a prototype. Whether you will immediately send it to manufacturing lab for producing 1,000 copies of those cars, obviously not. So you have to send it to a testing system, and that system can be varying depend on the car type. Suppose you want to get a nano car and you want a Jaguar car also, right? But it does not mean that nano car is failing in some test, you cannot produce it. But yes, it will be failing some test. You will not sending it to the robust testing center, right? There is a F1 car also, right? Now, if you want to test F1 car, you'll test lot of different parameters or not. Speed, its wheel, right? Engine, everything you will test. When you test a nano car, whether you are going to test on all those parameters, obviously not. You will test on less parameters. Understood? So design verification depends on your design also, design demand. So RTL design is for, let's say, Bluetooth chip, right? So whether we need to design, whether we need to test on all different parameters which is related to CPU, not required, right? Only those parameters we are going to test, which is specific to design only. So for that, they will write test cases, right? Test cases means, suppose you have a system here which has some number of inputs, some number of outputs, right? When we can say that the system is functionally correct, this is a system, right? So you have inputs, you have output, right? So what is H? What is H? Don't forget about all those terminology, simple concept, right? There is one, any system, you have read control system, right? What happens? So there is one system, any system depends on two things, right? How your output is behaving and based on what? Your output is behaving based on the inputs given to it or not, right? No, it is same. The design verification team will do lot of things actually. There is a assertion, there is a formal verification, there is a functional. See, formal functional verification and formal verification both will be done. It's not like separate teams are. That is done by the DB team is very big actually.
Okay, so formal verification is part of design verification.
Everything will be done. So major check is functionality check, right? If functionality check fails, design that is done by design verification team. They will also do assertion. There is a term called as assertion. The DB, if you have anyone, you can. The assertion is also there. So they have different methods to do assertions also. Will not go there in DB. Okay. So see now in inputs, right? What? So when we can say that the system is passing, when it gets a desired output based upon all possible inputs. Let's say your mux is there. How many inputs and how many outputs are there? Right? Any 2:1 mux is having how many inputs? 3 inputs and 1 outputs. So what is the desired output based on all possible inputs? What are all possible inputs? How many all possible inputs? 2 to the power 3 or not? So total number of possible inputs are 2 to the power 3. So how many test cases? How many test inputs? 2 to the power 3, right? So if you have verified your design for all these test inputs, that is 2 to the power 3, right? And you're getting the desired output. But who will tell whether this desired output is correct or not? Who will tell the truth table, right? So whether you are getting the desired output or not, it is validated based on logical truth tables, or it is also called as LUTs, lookup table. So lookup table is another term for truth table only. It is not, it is fancy name, that's all. Okay. So once you are getting the desired output based on all possible for all possible inputs, then we can say that mux 2:1 mux is functionally correct. Your system is functionally correct, right? Now what is coverage? They will tell coverage also, functional coverage. It means, yes. So let's say 2 to the power 3 is there. So 2 to the power 3 means what is the number? 8, right? So 8 out of 8, let's say only for 7 inputs I am getting the desired output. One for one input I am not getting the desired output. It means what? 1 out of 7 is a failure case, right? So what is the functional coverage here? So 7 out of 8 is my functional coverage. What is the percentage? Right? Something around, we can say 80 to 90% we can take, something, some range we am giving here. So this is what your functional coverage percentage, right? So the RTL, the design verification team, they will have certain limit also. So usually it is near to 98%. Okay, 100% achieving 100% is very difficult when we are working in very complex design, processor design. Never you will never get 100% of functional coverage. So 98 to 9, more you get, it's more better actually. So 98 to 99% of functional coverage is acceptable for design. So if you are getting this value, then it moves to next stage.
So if the cross it, then it will pass.
It's a pass. If it is failing, if it is going, see, not only you are getting desired output, you should also meet the functional coverage also. So here we are talking about only 8 possible inputs, right? But in processor, it can be in thousands also, right? It can be hundreds also. For that, you cannot write each test cases one by one. For that reason, only design verification plays an important role here. So they will write different, what we say, protocols to cover all the test cases, right? So if there are 1000 inputs, 2 to the power 1000 is a big number, right? You cannot write each test benches for each test inputs. For that only they have protocols. So there are a lot of methods like ATPG method, automatic test pattern generator, random input generator is also there. If you have worked in MATLAB, right? You have worked in MATLAB, anyone? So there is a lot of variables where it develops random sequence of inputs, random input generator, automatic test pattern generator. That tool is very useful in generating these inputs, right? So that ensures that no possible inputs is left out while verifying our design. Understood? So that these, just I'm briefing what these people do. Okay. So achieving is what? Achieving a good coverage, and your design should functionally pass. So if your design is functionally passed, right, then it goes to synthesis. Right? Now it comes to synthesis. Now what happens in synthesis? Still this till this point, your design is what? Technology independent. So after synthesis only, we will say that your design has become technology dependent. Why? What happened in synthesis here? So what is happening? Just for an example, right? If you have a, let's say, okay, mux only, or some logic gates like AND. So you have AND here. Whether it is having any physical information here in RTL, in front end, no. Right? Now synthesis, what synthesis is doing? You have AND here. It will map AND with technology dependent library. Right? That is called as .lib. Tech dependent library. It will get mapped with technology dependent library, right? And it will be mapped. Technology dependent library means what? So it will have both logical information, and there is another file which will have physical information also. Now this physical information is purely dependent on what? Technology, right? Why? Because now here your device will have height defined. Your device width will be defined. All this height and width of your device is coming from technology, coming from feature size. If you're if you're working in 180 nanometer, right, and you're going towards 90 nanometer, what will happen? Feature size will change, so as height and width of device will also change. It will also get reduced. So, right. Suppose Suppose in 90 nanometer scale for this AND in library, it is 2x of area. Wait, not 2x, x of area. Let's say you have cell area of x. Now in 180 nanometer, it might be double of what 90 nanometer is. So area of this one AND might change, right? It will definitely increase in 180 nanometer. All this is because of what? Channel length, feature size changes, everything gets changed. This is very important point. That is why we say if technology node changes, complete design cycle is what? Washed off, means reset. Everything, your input files, your tools, everything has to be updated with respect to technology. So the first and the golden reference for any physical designer is the technology. Understood? So whatever you are doing, whatever you are designing, it should be first and foremost priority goes to technology. Then comes lot of things like you want fast processor, you want slow processor, you want this feature, you want that feature, you want these many cores. That is all with respect to design aspect. But first you should meet what whether your design is manufacturable or not, right? That is the first hurdle.
When you
Hmm.
generally the logic complex A is something question is there, right?
Hmm.
For the equation. Because this, let's say you have a box already in your checklist. So it will map to the box or it will use NAND gates to connect it.
Good question. See, this is a mux, right? So in mux, suppose you have written a if else case, right? You've written something like if else high level, and you have written a Verilog code in behavioral model, right? What is that behavioral model? Which is written in high level language. There is no logic itself is not defined, right? Now, how this will be mapped with technology? There is no logic defined. Let's say we are not considering gate level also. We're taking behavioral only. Now, if you see if else, so it will be interpreted. So what does synthesis do? Synthesis is nothing but translation, right? It is a first it will do translation. It will interpret that there is a conditional statement of if else. It will translate into some intermediate logic. Those are called as GTEC cells, right? Generic cells. Those are also called as generic cells, which is not technology mapped, which is not having any physical information. It is a G cells. So after converted into a generic cell, then that generic logic, it will be converted into mux might be, right? Let's say mux it has converted. Now this is a generic logic. Now this generic logic will be mapped with the technology based library, right?
How the logic will be logic will be computed to mux directly or
That is what algorithm is written in synthesis, right? If you get a if else, it should be interpreted into this logic. That is how it is defined. If you have a clock in design, right? If clock is defined in the code, then that should be interpreted into a sequential logic. Now, which sequential logic? Is it a D flip-flop, right? Or different logic, different sequential logic? It all depends on, again, inputs and outputs. It will convert into Boolean, that is algorithm, which it follows. Tool to tool, tool to tool, it won't change. What I said, tool has a least effect on changing the design things. So this is coming from the algorithm which is playing the role and the inputs which are used. If tool, yes, tool can affect in that way. Let's say the flow which is following, right? That algorithm which is followed, whether it is fed properly in the tools run or not, tool flow or not. There it can see, you can see the problem. That is correct. So if you see the design compiler, Synopsys design compiler, it follows certain type of flow. That is a tool flow, right? If you see a genus is a synthesis tool from Cadence. So it follows a different certain type of flow. But majorly, what is the three stages? First is translating. Translating means what? Translation of high level language into logical design, right? That is what generic. So this thing happens there also, here also. So there is no difference. How it is interpreting based on same algorithm. It is no difference in Synopsys or Cadence. Only thing is that, so how they are getting the variables, how they are crunching the data, how they are treating the inputs. There it might get some mistakes, right? Taking the wrong variables, taking not storing properly. Right? There it can get some headache. So input should be correct. So as a physical designer, that should be, you should be checking all those things. So tool wise, we'll see very less challenges because tools are that much of matured now. right? You can say that 10 years back, you can see problems related to tools. Nowadays, very less chances because tools are very much matured unless and until technology is changed.
In synthesis, do we have logic optimization?
Hmm?
Logic optimization. It will have, right?
That is what? Logic optimization, that is nothing but
It's not optimization.
it will have optimization. Yes. First, yes, that is correct. First, it will translate, then it will map, and then it will optimize.
The basic code of the PM. How many papers?
It is not basic or not basic, we are telling it is a part of design cycle. You need to follow. You cannot tell this is important, this is not important. You cannot tell RTL is not important, this is basic or this is not basic. Each and every stage is equally important in this design cycle. You miss any part, you will not reach, your chip will not reach to the manufacturing plant. Of course, it will have. Of course, small change in PV also it will affect. Small change in PD also, floor plan also it will affect. Right? I'm telling you, you should not tell this is great, this is less great, this is important, this is less important, this is basic, this is not basic. Each and every small substage, even sub to substage, is very much important. You cannot skip it, you cannot ignore it. You miss it, your design gone. So it is a flow from top to, like it is coming from where? The architecture specification, architecture, and then RTL. It is following that sequence, right? You miss any one of these, you cannot move to next stage. That's all. Okay. So final output will be what? In chip designing, as a physical designer, your output will be a GDS2 layout, right? Once design went to synthesis, it will go to physical designing. After physical designing is completed, you will have sign off checks, and then you will get a GDS2 file, right? GDS2 is nothing but a graphic design file, right? What it has? It has information about layer, nothing else. You tell me device? No. No device information. So GDS2 is nothing. I'll show you. I'll explain. I'll show some. So it is not two. We'll say two. It is two eyes actually. Okay. So people will call it as GDS2, but it is not a Roman number. It is two eyes.
It's okay, I think you can move forward. If it's only for me, maybe you can move forward.
I anyhow I have to explain that. Okay. So see, GDS2 is nothing but the your output final file, right? What it consists? What it consists?
It's kind of
Is it a readable file or non-readable file? It is a non-readable file, right? It is a binary or non-binary file. It is an encrypted file, right? You cannot read it. But what kind of information is encrypted? That is only layer information. There is no device information, as I said. Why? What is the reason? You will not find and or all those are for the why? Hmm. We have designed lot of done. We have done lot of hard work. Then, but that is also not there. Means what? Only layer information is there in GTS2. That's what we are discussing from last hour, right? So fabrication or foundry is completely layer based fabrication. Yes, correct. Manufacturing layer info is enough. Why? Because foundries are manufacturing and fabricating only based on layers, substrate, then envelope, diffusion, poly, metal layers. What I told, design and manufacturing is three-dimensional, not two-dimensional. Okay, manufacturing plant, fab labs does not know this is NMAS, this is PMAS, this is and this is it does not care also, right? What it cares, layer is present or not, layer information is mapped properly or not. That's all. Done. End of story. It does not care which device is connected or what not connected. Layer information is there, properly mapped. Which layer is connected, it will connect. That's all. So GDS2 only have layer information or its connection. That's all. Clear? That is sent to what? A fab lab. So in the final output, what you will get? Final output means once GTS2 is sent to fab lab, right? It is sent to fab lab. What is the output? What is the output? Yes, it is not chip. It is wafer, right? Of course, yes, you can say chip also, but after wafer you will get what? Chip. Now what is wafer? Yes, you can say kind of right only, but it is simple. If you have seen potato chips, right? You will also call it as wafers. You might have purchased Lays or something like that, right? It is what we sometimes some people will call it as wafers. Why it is called as wafer? You take one potato, how it is done, how it is processed, right? You take one potato and they will slice it into thin sheets of potatoes. If you slice this, you will see, yes, Kiran. So you will see spheric, I mean the oval-like structure, right? So this is now then processed and then you get a potato chips. Similarly, in semiconductor, what happens? The source of semiconductor is what? Source of silicon is what? What is the source? From where we are getting silicon? Sand, rocks, sand, right? Sand is abundant in nature. That is why silicons are cheaper compared to another semiconductor. What is that? Germanium, right? So that is why we are using silicon. Germanium is better than silicon. What is the conductivity? Right? What is the threshold voltage for silicon? Correct, Kiran. 0.7, right? And what is the threshold voltage for germanium? Which is what? It is conducting faster. It will start conducting faster or not if it is 0.3. 0.1 depends on different material. So material have also different qualities. Okay.
Tweak the result of different voltages, right?
I
Sir, do
am
we need to
now
mention it
what I am
is
discussing. It is related to semiconductor physics, device physics, material
hello?
physics.
Hello?
Yes, yes. Tell me, Alex.
Sir, do we need to mention it is as electronic volt or 0.7 volts?
Volts only.
Volts only. So because of few textbooks, they will print as 0.7 EV.
Oh, like that. Huh? It is just a way of telling. Electronic volt means it is very small, right? That is why they will mention that it's electronic volt. If someone
Oh,
says volt, so you can understand that it's electrical voltage also. Usually, electrical voltage is higher in number. So that is why to just for identification, they'll keep EV. It is similar to volt only. It is not some different thing.
Okay, sir. Thank you.
Okay. So what we are understanding, it is coming from sand, because sand is cheaper, right? Abundant in nature. So you can extract what? Silicon from sand. How it is done? So they will take all this sand, they will remove all the impurities or unwanted materials from sand like iron and other things, right? Everything they will remove. They'll only get only those sand particles which has silicon in some percentage. Now they will melt all those sand, and they will get a form called as ingot, something like this, a cylindrical structure which is called as ingot. This ingot is sliced, a thin sliced multiple number of times. So after it is a cylindrical structure. After it is getting sliced, you will see a circular thin sheets, right? Those are called as wafers, right? Now each wafers goes through a fabrication process, right? Suppose this is a wafer, and there will be a UV light, and UV light is going to pass through what? Pass through what? A lens. Mask. What is mask? What is mask? It is like a stencil. You have used stencil during your geography classes to draw the map, right? Or in Deepavali, have you drawn the rangoli using stencil? Right? You will add colors on that stencil mask, and some colors and pattern will be drawn on ground or not. Exactly same pattern or not, based upon what colors your, yes, ABCD stencil also. So that design will be imprinted on ground. That is nothing but a mask. Now some another smart person will come. That person will take two stencils, two rangoli stencils, right, to have a unique design. First pattern, first pattern is drawn using one stencil. Another person will take, she will take another pattern stencil. On top of it, they will keep it. Again, they will add some different colors. Now you will see a different, completely unique pattern or not, combining all those things. Similar thing happens here also. There is not only one mask, there will be a set of multiple masks. Based upon what? Based upon what? Mask is based upon. There it is a rangoli color. Here we are having layers. Ultimately, what I'm telling from starting onwards, fabrication is all about manufacturing and fabricating layers, layer by layer, layer by layer. First layer. So any silicon is by default what? It is a substrate. What substrate? P substrate or N substrate? By default, it is a P substrate or N substrate. Device physics, semiconductor physics. It is a P substrate, right? So on that, then you will be creating N-well diffusion layer. How you will create it? It is a P type, right? How you will create it? You have to first etch off some part. Etching off means what? Taking off some part from that substrate. Etching off means what? Removing some of the material from there, right? And injecting it with what? Injecting it what? With what? Highly doped material, right? How you will get an N diffusion and P diffusion?
We will change the concentration of carrier.
You will highly doped with pentavalent or trivalent. Based upon that only you will get N diffusion or P diffusion layer or not, right? In that way, these all process happens in fabrication itself. What you have studied, right? So that will be seen in these manufacturing plants, in this fabrication. All this will be followed, right? Like that, layer by layer is fabricated on this chip. Whether a wafer, single chip will be fabricated on this wafer? No. There will be hundreds or maybe thousands of chips will be present here. Right? Now question is, so these light will be passing through mask and lens, and it will be keep on imprinting layer by layer till what interconnects metal layers from bottom to top, right? Once that is done, once fabrication is done, so you will see multiple number of chips are fabricated, same design but multiple number of chips. Now whether all these chips will work same, right? Some may be default also. See, even you have, if you see a farmer, they grow rice, wheat, and this thing. Whether all the part of their farmland gives same amount of production, some give like 1 quintal, some give 2 quintal, some give three quintals also, based upon the environment how it is grown. Maybe some less sunlight, tree shade is coming, less water is given. So a number of factors can play to give the production, right? So here also we cannot predict exact number of production that it will give 100% correct number of chips after getting fabricated. So definitely some will be faulty also, right? Some will be faulty also. So mostly what happens, the chips which are there in edges, right? They are complete failure, right? They are completely failed. That is for sure. Why? Because the chips which are not complete in area, they will get failed because it will cut, right? It will cut like this.
I haven't found out. In that case, why can't they get a
Rectangular.
kind of wafer?
So if you use rectangular based wafer, it is not friendly for the process design process cycle. That is why the square based is not used, right? That is why circular is used. That is one reason. There are n number of process based reasons are there. That is the reason circular is more preferred. Also, this is one thing. Also, it is found that once we are using square based wafers, right? What is happening? It is found based upon multiple number of batches of research that circular wafers gives more yield compared to the square based wafers. Because I'll tell you, because the chips which are fabricated here, right, which are placed in edges, in boundaries, these are definitely going to what? Get a default chip. These are definitely going to be getting a defaulted, means getting damaged. Why? Damaged. All the edges chip will get damaged. So it is found that compared to circular ones, more number of chips are getting damaged in the edges. If you draw a square also here, right? Understood, right? So that is the reason we are following circular based wafers. Okay. Now this is for edges. Now it does not ensure that chips which are present in this wafer will also pass. Some chips will be failure inside wafer also, right? Maybe one or two. Yes, so like I said, Kiran, so process based also there are some reasons, right? As well as yield. Both are the reasons we are not following square based wafers. So some of the chips will get a failure chips. You will get a failed chips. Now what is the yield? We are saying lot of times, right? What is yield? Yield is nothing but number of good chips out of total number of chips, right? What is the good? So ideally your yield should be 100%, means best case, but it is never achievable. So what we are trying to do here, we will try to achieve the max yield percentage, right? So how this is possible? So there are different levels, different levels which are responsible for failure or good chips. So one is process, second is shape of wafer, and most important as a physical designer, which you should worry, that is a design level. If design is having lot of DRCs, definitely you will get more failure chips. If design is having lots of shots or different, like you haven't followed the guidelines which is given to technology, definitely yield will be less. Understood? It is like, see, when we are doing farming, right? There are some guidelines given to you. If you are growing a rice, you should give more water at certain amount of time. But you are not following that. You are giving water at night time and you are giving less water. What will happen? Yield will be less. If you are growing cotton requires what? Less water. But if you are giving more water like a rice production, what will happen? You will get less cotton, right? So guidelines are there in farming, also guidelines are there here also. And but these guidelines are provided by foundry technology, which designer has to strictly follow it. There is no other option.
Chips inside, and there are 40 of them. On what basis they decide that? How they check that?
How to check?
How do they check? Which are chips are bad? Do they have some kind of?
So once chips are fabricated, right, they will cut it using machinery. They will cut it in slices, right, into single chips, separate. Now single chips will be separated. Now individual chips, yes, that is called as dicing, correct? So after getting diced, individual chips will get a packaged into what some kind of polymer or some kind of plastic based packaging is there for each chip. The chip size is what? Chip size is your nail, a single nail finger, right? What is the size? If we talk about processor chip, it is the size of your nail, that chip size. But if you see motherboard of a computer, you will see it is size of a matchbox. That complete, that is nothing but a packaging. That is not a chip size. Inside that matchbox size packaging, you have a chip size of nail finger, right? Then why this much of area is given, right? That is all related to EM and electrostatic things, right? And different resistance related. So that I will discuss during advanced thing. But if you see, there are a lot of pins, right? Different white color pins. So if you see, this is what packaged, and there will be a lot of these pins. Now this will be getting tested before getting for like going into market, right? It will be properly tested and then it will be sent to market. They will not send to market with the failure chips. Of course, now this is not only about the failure thing. Definitely, whether all these chips will be of same quality. Of course, passing. Now we will talk about not about failure. Failure is gone. Let's say all these chips are passed. Out of those, all will be behaving in same quality level. Definitely there will be some change. See, you are growing rice in one farmland, another farmland. Whether quality of rice will be same as this one, we'll segregate or we'll segregate. This is the best quality rice. This is the second best. This is the third best. And similarly, here also we will get, if all chips are, let's say some amount of chips are passing. Out of passing chips also, different performance level will also there, right? That is the reason if you go to any showroom, right? So they will not give you big discounts in chips, right? Intel chips, i3, i5, right? If you go to some local shops, they'll give you heavy discounts, right? On that same computer desktop. Nowadays, now it is purchasing desktop. But earlier days, if you see in your school days, maybe, so you're going to purchase a desktop. If you go to authorized vendor, right, they will not give you discounts because the chips which are fabricated for same design is having different performance level, quality level. So they will segregate into tier 1, tier 2, tier 3, tier 4, tier 5, right? Or grade 1, grade 2, grade 3, grade 4, grade 5. The grade 1 chips, the best quality chips, they will send to their direct authorized vendors, right? Which can be purchased from there. That they will keep at higher price. The grade 3, grade 4, and grade 5, which is of less quality, less performance, which have a less lifespan, they will keep a less pricing tag and they will sell it to local vendors or the indirect vendors. That is where you are getting the discount. Understood? That is the difference actually. That is not nothing to do with design or technology. That is more of business or market level strategy they play. Okay. So let us move ahead.
The quality is the same.
Sorry, what is that?
Is that quality same as you told that in grade 1 and grade 2?
No, that is
No,
what.
authorized.
So based on the performance, based on the quality, they will segregate into grade 1, grade 2, grade 3.
Okay,
Like
okay.
this thing happens in farming also, if you see. So in Nagpur is known for production of oranges, right?
Oranges.
So the best quality oranges which is produced, they will export it to foreign countries. You will not get it, right? As an Indian, you will not get the best quality oranges. They'll export at higher rates, higher price. The third quality, the grade 3, grade 4 oranges will remain here and sold it to local market. That is why those are what cheaper in rates.
Okay, sir. Regarding this Intel and AMD, so what is the difference?
Like I said, AMD is a fabless company and Intel is a design. It is also having its design setup as well as fab also. So it is capable of both designing as well as fabrication. Whereas TSMC is purely fabless, fab company. It does not do any designing.
Okay, so regarding the performance, which is the better, sir?
Performance means what? I'm not getting performance of chip, performance of company. What you're asking?
Performance of chip, sir.
Performance of chip means what? Company based you are telling?
No, sir. So when we go to buy any electronic devices, at least a laptop,
Oh,
so we'll
like
be having.
that we cannot tell. Means Intel is having their own strategy and own design cycle. Complete flow is different, right? Technology they might be using different. So if you see AMD is using what? They may use TSMC, they may use Samsung Foundry also. We don't know, right? If you're using TSMC Foundry, so you have to follow TSMC guidelines. If you are using Samsung Foundry technology, you have to follow Samsung Foundry guidelines. Why? Because their machinery is different, setup is different, right? Not only this, the design course might be different, right? So let's say both are designing the 8-core processor, right? The clock frequency might be different. In one design, your clock frequency is not achievable. Let's say you're designing a 4.5 gigahertz processor, right? Whereas AMD could not attain that frequency. That is 4.2 gigahertz they have attained. In that way, you can say that performance is less. So performance is always you have to tell the specification also, and that is measured based on frequency and timing, right? If any chip is giving you better performance, then you can tell, okay, AMD is better processor. If it is having same cores, you cannot compare quad core and octa core together, right? It should be same core and same level of frequency, same number of logics, same number of this architecture, or we'll say the design specification, right? If you want to design a 50 megapixel camera design in your processor design and you're comparing with the 100 megapixel camera, it does not make sense. So everything specification wise needs to be same, then you can compare that which one is better. Then you can comment based on frequency and timing on it. That is the last thing. If you want to compare, I'm telling. Otherwise, we cannot tell exactly. So that's where the competition comes, because some companies are there, they can achieve a higher frequency, good design, but they cannot achieve the robustness. Intel is good for robustness, Intel chips, but they are not able to compete with the AMD, right? because nowadays AMD is producing a less or cheaper cost chips with a good frequency, a good performance, but we are not sure about its robustness. You can see this is also AMD laptop, and this is continuously flickering. It's not shown here, but the screen is flickering. So that is the difference. Means I have worked in Pentium 4, Pentium 3 kind of desktops also. The robustness is like anything. 10 years gone, and the desktop is, you see in government offices, the desktops with the box kind of desktop they will use. They're using Pentium 4, right? Pentium 3 also, if you go in very remote area, post offices, right, you will see Pentium 3, Pentium 4 they are using, and still they are using it. What is the reason? Performance wise, not good, of course, but robustness is excellent, still in working condition. So if you want to achieve something you have to lose it. That is simple thing here. Okay. So low power devices, nowadays we are in the world of low power devices. The major challenge is this only, right? If you want to go into more low power, you'll get a good performance, but in cost of what? In reliability, that will be less. It will not run for long period, right? Your mobile phones also, right? After 3 4 years you have to change it. It will be like lagging, and something screen issue, some issue will come definitely. You cannot use that phones nowadays for 20 years, but in our father's generation they're using some Nokia phone for 10 15 20 years, still they can use it. That is reliability, that is robustness, but in cost of what? Performance and features. So if you want low power, more features, more performance, you have to leave something. Compromises has there. Right. That is universal truth. So this is GDSS2, we have already discussed. I have told those points. So these all points I have discussed here. Right. So ASIC design, what is ASIC? So what we were discussing till now, it is nothing but a ASIC design flow. ASIC design flow is nothing but application specific integrated circuit, right? So if you see in the world of semiconductor design, in the VLSI industry, all chips are designed with respect to application, that is purely commercial in nature, right? So if you want to design a Bluetooth chip, right? Earbuds, wireless earbuds. So your chips should be low power, right? It should be small in area, right? And its performance, its connectivity should have more range. These are some specifications, right? So first stage is always what? Specifications. So specification must be clearly defined based on what? Application. If you want to design a chip which is for 6 cents washing machine, right? Once you have pressed button, quick wash, it should wash everything, wash, dry, clean in 30 minutes. So how it is possible? So you can design that kind of chip with respect to the application need, right? Similarly, nowadays we are having ACs with inverter, right? So every gadget, you name it, nowadays every gadget is having chips, semiconductor chips. So that should be application specific. 80% of semiconductor market is on commercial market, is on commercial use. That is for public, right? That is phone, tablets, washing machine, TVs. Nowadays every TV is having a VLSI chip. There is no, those days are gone. That CRO based tube TVs were there, right? Nowadays, each and every electronic gadget is having a VLSI chip. In coming 10 to 20 years, everything, even your electrical appliances, electrician will also come with ICs in their bags. Nowadays, they're not coming, but you will see that in future. If something gone wrong, they'll change the VLSI chip. Like that will happen, right? Nowadays, some people are doing also smart homes, we'll say. So they don't have switches, right? Just yes, home automation. You go at someone's home, you tell switch on the light, switch on this light. That also they have specified. Switch on this TV, make a phone call to this person. So that much of level is attained only because of VLSI chips. Even in cars, we are having what? ADAS system. What is ADAS system? Autopilot mode driving, right? So you don't have to hold the steering. It identifies lane, everything. In Indian roads, first Indians has to be changing their ethics. Forget about technology. No matter how good technology that one train came, right? Vande Bharat, that people are poking all the seats and taking out all the sponges from there. If people are not changing, no technology can help them, actually. You have seen auto drivers in Indian roads, right? How they make turns, sharp turns. So I don't think it might work in highways in some cases, but in city roads, I don't think ADAS will work. But of course, in mid cities where less population is there, okay, but there also we cannot say some cattle, some boy, young boy or kid can come on road, right? How you will like things every time it will keep on braking. So that is the thing. So there are some countries where very less population is there. No one is there, no car is there, no cycle, no bike. Still, they will follow traffic rules. But here, no one is there. Police one, they first look to what traffic police person is there or not. If not there, they'll jump traffic like anything. For that reason, they have mounted cameras on traffic lights. Still, they will jump because cameras are not working. No. They also know one time they will jump, they will not get any challan or what we say, that fine or something. No, they will understand cameras are not working, will jump. So cameras are also not working. Why? Because to maintain that camera and that complete monitoring system, that needs some budget, a good amount of money. Cameras are not for lifetime. It is in rain, sunlight. Definitely, it has to be replaced, right? Once they have launched it, when we don't know, till now, after 5 years also, there is no maintenance, no replacement of that camera. Definitely, it won't work. So crores of money is required for maintenance also. That is for only to like scarecrow. That cameras are become scarecrow now. So okay. So then comes architecture, right? So architecture like, so what are the things required in any complete design, right? Suppose there is a processor. Processor required what all things? Audio, video, graphics, right? Connectivity based system, CPU, right? Clock, which will process the clock, right? And what else are required? Memories, right? Cache memory, RAM memories, and what else are required? You are using phone, right? When you are playing any game, you should think how many hardwares are active, right? If I can show you something. So if you play some game, how it works, I'll tell you. If you play some game, let's say PUBG, which is very popular, everyone knows this name, right? Let us go by this. So there is a chip inside your mobile phones, right? When you open this application called as PUBG, what happens? What all hardwares are active now? Everything, right? Everything is active like anything. Yes. So your audio video is active, that hardware. Main is what? CPU. It is active. Then memories are required or not? Graphics, a good graphics is required. And sensors, right? Control systems, and many things. There are many things. So if you're using camera, you also need camera system in your chip, right? And battery management system, right? And What you are using phone from day to night, right? Many things you are using, you should think with that respect. So everything is there which is controlling your hardware in your mobile phone through this processor chip. How you are seeing that there are different modes of power, low power mode, ultra saving power mode, right? You're seeing or not? What happens if you switch from normal operation mode to I'm not understanding. So we'll ignore. What happens if we have a normal power saving mode, right? And suddenly your battery drops under 10%, right? Now they are giving some feature called as ultra saving power, ultra power saving mode or power saving mode. What happens if you switch that mode?
The back.
That is all application program software thing. Something happening in hardware. That is why it is saving or not. Ultimately, what is draining your power? Is it the application? Is it the software? Is it the programming? No, it is the only and only hardware usage. You use more hardware, you use more circuits, you use more logic transistors, then more power dissipation. More the number of transistors are on for more longer period, definitely power dissipation will be more. That is the reason when you play PUBG, how many, what is the amount of transistor which is getting switching on and off, on continuously, right? What is the amount? Your audio video is continuously on, your CPU is continuously calibrating the graphics which you are playing there, right? Your memory is usage suddenly goes high, right? Graphics is using sensors, so there are gesture control gamings are there, it is also in use. Control systems are now it is getting activated, right? Camera it won't use, right? Battery management system is taking more effort to optimize the battery usage, right? So almost 90% of your hardware is working very hard here. So what happens when you play PUBG? In half an hour your battery drops, like the capacity drops like anything, right? Why that happens? Because of hardware usage only. Now you only do WhatsApp or texting, right? Full day, what will happen? Battery will drop at same rate? It won't, right? Because battery hardware usage is not there. If you are only doing texting, these systems will not get activated, right? Sorry, not CPU, CPU will be there. Audio, video, no, not required. So it will be switched off, right? That much amount of memories are not required. So RAM will be reduced, right? The usage of RAM. Graphics not required. Sensors not required. Camera not required, right? So what ultimately power dissipation is less. Now, once your battery is down to 10%, right? Now you have switched to power saving mode. What happens that time? So automatically it limits your RAM. It will limit some of the features. Means what? We will say some of the features like it will go into silent mode, right? It will reduce the luminosity of your what we say that brightness will be reduced. Earlier you are using this much of brightness, right? 80% brightness, it will reduce to what? 10% of brightness in order to save power. But how it is saving? Reducing from 80% of brightness to 10% means what? The graphics hardware, the transistors, number of transistors which is used to design graphics design, right? That is less now. Suppose there are 100 transistors which is used to design a graphic chip, graphic system, right? Now out of 100 transistor, only 20 transistors are on, 20% transistors are on. 80% is completely off, not in use. That is why you are getting what? 10% of brightness. So automatically power dissipation will be less. So that is how power is saved. Here everyone, how it works. So everything revolves around what? Hardware, hardware, hardware. If hardware is properly designed and optimized and controlled also, then you will get the best out of it. That is what they have done. Clear? So this is, all these chips are planar based chips, right? Planar based chips means it is like this, single plane chip, means everything is fabricated on same plane. So, but this has a limitation. Suppose in future, now I want to design a chip with the 8.8 gigahertz. Right now it is not there. But let's say for a mobile chip I want to design, definitely I need to use more number of transistors or not. So earlier for 2.2 gigahertz, for this much of area A1, I am able to design a chip, right? Whether with the same area I can attain 8.8 gigahertz? No, because transistor count will increase. I cannot accommodate those count of transistor in this A1 area. Definitely I will require what? More area or not. So that will increase the area of the overall chip. If the chip area is increased, what will happen? Cost will reduce or high. If area increases, cost will increase or not? How?
Nowadays, the chips are becoming smaller.
Wafer.
They are becoming faster.
Yield.
Yeah.
Right? If you have a smaller areas, so you will have more number of chips or not. Right? If you have bigger area of chips like this, you will get less number of yield. Right? So if you get more number, more profit. You can reduce the margin. The cost price can be reduced. The selling price can be reduced here. If you are getting less number of chips only, see that single wafer fabrication takes a long process and lot of resources in fabrication lab. So in that single wafer, if you can generate more number of chips, it is profitable only. In that way, if area increases, your cost will also increase. It is not a good thing. Of course, you can achieve 8.8 gigahertz with more area, but whether it is feasible, so you will get a phone with a 5 lakhs, 10 lakhs rupees phone, but people cannot buy it. It is not consumer friendly. So commercial market works on consumers, masses. If masses are capable of purchasing or not, purchasing power is there or not. That is also very important part where designer needs to understand. They should not, okay, I can design this 8.8 gigahertz. You give me this much of area. So I will carry a suitcase based mobile phone then, right, to get 8.8 gigahertz. That is not feasible, right? So nowadays we have different technologies also. So instead of CMOS, now they are working in FinFETs. So nowadays you will see GAFETs also, right? So there are different technologies now, big technologies. So CMOS technology is different, FinFET is different, and GAFET is different. But base of all this technology is what? CMOS. To understand all this, first you should have good grip on CMOS. Clear? This is one thing, one technology. This is single planar based chip. Nowadays, we are also having multi-planar chips, right? Yes, those are called as three. Even in Synopsys, they're working in some for some IPs. You can check, right? So there are multi-planar chips also. Those are called as 3D ICs, right? So what is the advantage here? Now that area thing, we are expanding on the horizontal x-axis. Now we don't have to expand on x-axis. We'll keep the area same. We'll move vertically. So like that, our device size will remain same. Vertical growth will be there, but that is okay. We can get what 3x of area. Earlier we were getting what A1 of area for single plane. Now you will get what 3A1 area. 3x. Understood? The complexity can be increased in cost of same area, but with the vertical growth. That is the purpose here. 3D. That is where they came to this part. Clear? Any question? So this thing we have already discussed, RTL design, RTL verification. So next, whatever you see here, it is the physical design, the placement, floor plan, floor plan, placement, CT routing, and sign off. So we have discussed this one, which is called as front end, and this is the sign off stage, which is a back end of the design, and the mid part, which we call it as a physical implementation or physical design, right? So it is basically first stage is always what? Floor plan, right? So this we have. See, this is a very vast subject. You cannot cover everything in one session. This is just a demo session to make you understand how VLSI industry works, how semiconductor things works, and how it is related with physical design. Understood? After knowing the base, after knowing from where it is coming, then only we can discuss physical design. If I directly start with physical design, so those who have already know the base or basics, they will understand. But many of you listening this for first time, I hope, right? It will be difficult for them. Okay. So I'll quickly just cover this in PD, then we can stop, take questions also. So floor plan is the first stage of physical design, right? In this, the logic or this libraries, once synthesis is completed, we will have one netlist, which will have all logical information. We are going to place all the standard cell libraries in the floor plan. Floor plan is deciding, it is nothing but the deciding of the core area before starting the design. How much area is required? What will be the core offset? Means from the core boundary. This is internal square you are seeing, right? It is called as core. The external square is called as die, right? This is a die, this is a core boundary. So it is nothing but the placement of these cells. We will say cells. Now cells can be any type, right? It can be standard cells, it can be macros, it can be physical cells, it can be memories, right? So how we are placing it, from where we are getting this cell information, how many cells are required, it is coming from what? It is coming from design file, .v file, netlist, which is the output file of synthesis stage, right? Everything is coming from that stage where specification,
After mapping, we will know.
specification, architecture, RTL, design verification, synthesis, and then comes. So our design is ready. What? In paper, like in circuit, in logically, right? But whether any physical work has been started, whether physical connection has been started, now whatever things has to be done, it has to be done with respect to foundry. Now it is a real picture. Wherever you are placing, suppose you are placing memory here, one memory here and this big memory here. So during fabrication, that particular memory will be fabricated there itself. Now it is completely purely physical aspect. Logical, of course, there timing is nothing but a logical aspect. Yes, logical is also there. Now physical has the more priority compared to logical, because no matter you have meet 8.8 gigahertz also, but physical you are failing, so it won't go to foundry. That does not make any sense. So first priority from physical design for physical design is to meet the physical constraints. Then you can see, okay, I am attaining 4.4 gigahertz, I am achieving 4.2, then you can, but without compromising physical constraint. You cannot compromise physical constraint. You can compromise somewhat logical constraint, okay, but physical constraint you cannot compromise here.
When you decide those plans, the size who will decide how much
A physical designer will decide.
of
You mean area?
which rectangular area,
Shape.
of the area, how much of it is needed for our implementation, or what ways to measure that?
Okay, that is all coming from the architecture. Okay, or specification, we'll say. So first stage is what? Specification. Here only it will be decided what is area expected, right? See, suppose the end product is nothing but a mobile phone, let's say, or computer. If it is a laptop, then we have more area. If it is a mobile phone, then we are very limited. We cannot use any area we want. So suppose they have already designed some of their phones, like the phone size, the screen size will be of this much of 15 or something like that they have decided. Now, based upon that, they will see out of my complete phone area, there are other components also, right? With respect to that, how much max we can have as an area which can be utilized for chip? That will be your specification area, right?
So it's like basic, roughly they will give.
Device, a product. It is coming from the product. Suppose you have a laptop, right? You have, of course, now you have more area. Of course, there are other components also. So how much possible or achievable area is there? The max area is there, which can be utilized for chip.
Let's say,
I'll tell. Wait, this is not end of story. Okay. So once you got this, now this is just a top level specification, what they are thinking. Okay. So this is the max. But always from this area, we can achieve to lesser area also. It all depends. Now it depends on the designer, how smart designer is, right? Now the given area is, let's say, X. A person can go below X also, right? It all depends on its designing capability. If he is a good designer, if he she is a good designer, the person can design in that much optimized way that he can reduce the area also, right? Now area can be reduced based upon what? Now the area is decided, right? Area can be reduced based upon logics. If somehow the requirement of logic is less, then area can be reduced or not. Now RTL comes, right? They will design something, they do not care about logic gates also, how many are there. They will write any complex things in behavioral code. When you will come to know, once it goes to synthesis after DV, right, and you'll get a netlist, then you will get a logical count, right? Okay, these many gates are required, these many logics are there, right? Then you will get to know the picture that these many logics are there, we cannot do this, right? Then again it will go back to this person, right? You do something and reduce it, and they will again calibrate it and they will give it back to this person, right? Usually this is very less. RTL, once it is developed, matured, it will be used as a repeated thing, right? Some modification. The thing is, this is one thing which will play in differing the area. One is coming from the product, one is coming from the RTL. Second, third is once you got the netlist, suppose now no returning back. Okay, now still area can be variated, right? How it can be varied? So based upon how you optimize it, right? So if more you use, then of course what will happen? Utilization will increase. So requirement will decrease. So that is how it comes. That is how a designer needs to be good designer, right? Then only they can save area, right? Now comes shape. How shapes will be there. So every time whether chip shape will be circular. So the top chip is always rectangular or square shape, mostly rectangular shape, right? The top chip means what? The chip top, the final product of the what we say product chip. That is always square and rectangular. Not always, I'll say 99%, unless and until it is a custom made chip. So if there are space programs and military based programs, those are not commercial chips. Okay. So in commercial, non-commercial chips are not fabricated in lower techs, 10 nanometer or 9 nanometer. Those are always in 90 nanometer or 180 nanometer. The guided missile chips are made in 180 nanometer, 90 nanometer. The tank, the beam tank, you see, right? Nowadays, tanks are also having VLSI chips. So they are using 180 nanometer chips. So the IBM based, which is set up in that, so they're right. So they are 180 nanometer chips, which will be further helpful in the military applications. That is the correlation actually they've made. The not for commercial, they will not make any commercial chips. Commercial chips, what is the demand of consumer in commercial chips? That it should be fast, low power, lightweight. If you want to achieve this, you cannot achieve reliability, right? So that is where lower techs comes. So shape, unless and until it is custom, space or military, then the shape will be like different shapes, right? Depends. Otherwise, 99% case, if it is a commercial case, then it is a rectangular or square shaped chip top. But in that, like I said, there are subsystems, right? In your chip, you have multiple systems in your chip, right or wrong, in your mobile phone chips. Now, whether these all will be in rectangular, that is not necessarily true, right? It can be of any shape. The sub blocks which is present in the chip can be of any shape, right? Depends on what? Depends on how it is partitioned. Understood? Means what? See, the number of memories, the memory area, number of memories may be more. The CPU area might be more, right? So audio video does not require that much of area, that is having some logic, not many logics required. So it will require some less area. So like that, it will be partition based upon requirement of that particular subsystem. So depends on the partitioning, the shape will also get decided.
You provide less than expect. So when the actual requirement, that if you want to go for X, so how do you decide how much extra there is for implementation?
If it is the X which is coming from spec, if anything is crossed above X, that project is cancelled. You can always go less. You cannot, if you are going above X, that project is cancelled. Hmm? Not hard rule. That thing is decided based upon market, profit, cost, everything. The top level people will take. Increase, they will not accept unless and until there is some scope, or unless and until they will have re-talks with the clients or vendors or the stakeholders they're talking to. That is not a single man decision. The complete ecosystem which is there on top. So so it's a very different cycle. So usually if they want to repeat all those things, no, the cost will increase like anything. So usually they will drop that. You go in anywhere, right? Increasing is not an option. You have to, then what is the, means what is the point of becoming a designer then? They'll ask you. And who made you designer? If you are not able to reduce the area, then if that can be done by machines also, some automation also. Why designers are required? Designers are required to fix the challenges, to improve the optimization, to make more profit. If you're not able to do that, then that is problem. So simply they will cancel that project or they'll drop that project. Maybe in future they will again restart it. Everything, they will not only see market, they will see the functional, logical correctness, the technology based thing, everything they will calibrate, and then they will give you some area value in specification. So if you are going above that, so all those things has to be done again. and they will usually not go with that because the cost will increase. Now every person has to involve again deciding that area. Okay, that is not preferable. Even if it is possible, it is not good for a designer to say that we want more increase the area. Specification area cannot be changed. See, in the block level area can be changed. It can be increased. So once the chip top is there, right? So that cannot be increased. Inside that you have multiple subsystem blocks, right? That can be varying. That you can increase, but remaining in that boundary. Yes, remaining inside the chip boundary, you can do anything, right? You can, yes. Reduction is always welcome. Reduction of overrun. They will be very happy if you are able to reduce. Because why? Yield, right? Yield will be more. If yield is more, then more chips, more profit. So they will be very, very happy. So it is all about what commercial based chips. All these companies you are seeing, right? All these are consumer or commercial companies that are targeting the mass consumers. They are not working on some medical based chips or the space based chips or military based chips. Those are completely commercial. That is what I am saying. 80% of market share is ASIC based or commercial based chips. 20% is space program, medical appliances, or military based weaponry. Okay. So this is floor plan. So after floor plan, placing the all macros, you have to place what? Standard cell placement, right? So means smaller logic, smaller blocks like AND gates, OR gates, right? So those are roughly placed and those are rearranged. So there is a term called as standard row, right? Yes, you can call it as site row also. Why it is called as standard rows? So these are called as markers. Markers of placing standard cells. It is the markers for placing the standard cell. It means what? Means you cannot place your standard cell like this. You cannot place standard cell like this also. Right? So it should be what? Integral multiples of site rows only. Integral multiples means what? It can be multiples of site rows, but it cannot be like this. These are wrong placement, right? These are the markers, and these markers are coming from where? Who is giving us? Foundry, strictly from foundry, right? So this site row, whatever height is there, site row height, site row width. So the width of these cells, right, which is present in lib and left, left, right? So this width is always integral multiple of site column width, right? Height of this standard cell is integral multiple of site height, okay? And it is coming from foundry. So this is called as legal placement of cells, and this is illegal placement of cells. So that also you need to take care in placement.
We need to align hydro feature with this hydro.
PG.
Create power rail, not in one layer. Will handle get middle layer, right? The power. So we need to align power with hydro or hydro with power.
No, there is, see, site row is different. Site row has nothing to do with layers, first of all. Okay, Question is quite contradictory here because side row has nothing to do with the layers.
Where electricity is there. So when PG is there, power. So power should be aligned with side row. Or we need to create some type of based on the PG structure.
Side rows are not created. Side rows are coming from tech only, right? So you can say tracks, right? Layers have nothing to do with side rows. Side rows has nothing to do with layers. Okay. What you are trying to ask is whether tracks, which track? M1 track. Whether M1 track is coinciding with side row or not. That is your question. Right? Side row and track is two different things. Track is nothing but it is like it is called as metal track.
Yeah.
So what is the purpose of metal track? No. What is the purpose of metal track? So these tracks are meant. So this is also a marker. Side row is also marker. Tracks are also marker, right? But side row is marker to place standard cell, and these tracks are marker to create layers, right? Which layers? Depends on which metal layer we are using, right? There are different metals also based on technology we are using. It can be M0, it can be M1, it can be M9, it can be M13, it can be M14. Based on technology, that tracks are different. Suppose this is a M1 track. Similarly, we'll have M2 track also. So this specific M1 track is a marker to create only M1 layer, right? So you can create only M1 layer on this track, right? Now, so there is a side row. Let's say this is a side row. What happens if your M1 track is here and here, next M1 track, and next M1 track is here? What happens in this case? Right? This is your side row. Dotted lines are side rows. So your standard cell will definitely sit on side row, which is integral multiple of side row. What is your layout of cell? So for that you have to go back to CMOS basics, right? So what is your layout of a CMOS or any logic or inverter? So you have PMOS and NMOS I have drawn. So there is a PMOS, NMOS, there is a VDD line, there is a VSS pin, VDD pin and VSS pin, right or wrong? See, just now I have drawn, right?
Yeah.
Where I have drawn? Here, see, this is nothing but layout of inverter or not. You have VDD pin, you have VSS pin. This is enclosed in one PR boundary like this. This is nothing but called as standard cell, right? Standard cell, inverter standard cell. Now, this will be placed or not here. Once it is placed, this will align with whether, so it is internally, it is having some layout, VDD, VSS. How it will get power? So M1, you are saying there is rails, power rails are there, right? Power is there. So here also we have power rails. On M1 track, you are having M1 layers where your power is running. Okay, VDD, VSS power is running. Now this is a VDD. This is what is this? This is VDD. This is VSS. Right? Now how this will get tapped with the power lines, PG lines? How it will get tapped? Not possible, right? Possible is there, it is possible. But every time what you have to do, you have to draw another layer and connect like this. You have to draw another layer and connect like this. Right? In that way, it will become very clumsy design. Better idea or smart idea is what? You can change the offset of this track, right? See, right now, what is the offset? let's say this is your core boundary, right? Right now, let's say you have offset of, let's say 0.5. Okay. So how much change I should bring? Let's say this is offset from the site row and the track is 0.2, right? So what change I should do? 0.5 minus 0.2, you will get what? 0.3. So if you take offset of 0.3 from the core, what will happen? Now this M1 track will be created exactly aligned with site rows. Now what happens? Now these all tracks will be coinciding with site rows. What will happen? Once when power planning is done, these power layers will be created, right? M1 layers will be created. Now it will be aligned with your PG pins, right? The device PG pins will be aligned with the power routes, PG rails.
So we need to change it PG only, not just the type of offset.
Track of
Yeah, track
offset.
That will-
Don't tell PG, don't tell other things. Shift the tracks.
Yeah, track level will PG level on the top of it.
It's
Yeah, that's what I have to.
clear.
First priority is side road, then we track based on the side road. Yeah.
Okay. Understood, everyone? So that definitely in PD Advanced I'll be discussing about the power planning. So it is more complex there. You'll understand how or other things affect your design. That is very important there. That is a good question. Many people have this doubt that whether how it will get the power then, right? So that is what the tracks can be changed, but site rows you should not change. It is coming from, like I every time tell, whatever coming from foundry, you should not disturb it. That's the simple rule. The tracks are not coming from foundry. The location of tracks are not. So that is in designer's hand. You can do anything you want with tracks, but not site rows. Hmm.
So they side road exists. Then you can get
EPT. So it is called as double patterning technology. So in lower techs below 10 nanometer, so there is a concept called as double patterning technology. You will have multiple rows. So all rows sides are in. So there you will see sides like the side rows, right? This is one side. Now you will have multiple sides like this. Right? Now different, right? Now cell types are different. Now one cell type can be placed like this. So there will be another different type of cell type, which is specific for this site only. It has to be placed in particularly this site. If it is placed in this site, if this cell type, particularly this cell type is placed, let's say this is 1, this is 2. If 2 is placed in this particular site, this is wrong placement. That is also one legalization rules. Okay, so placement is basically placing the right cells in right location. Suppose there are cells which are talking to each other, group of cells, right? Let's say there is a audio video uh, block design. You are designing a audio video, right? Now you have some circuitry and some logics which is related to audio, and there are some logics related to video. Now in your design, whether you are going to place those logics audio here and video here, or in audio also we have different audio logics, right? So there will be some ADSP, advanced digital signal processing unit will be there in audio video. So DSP processes, whether you are going to place here or audio here and video logics here and DSP processor somewhere near to here, which one is better? Placing far from each other or placing near to each other? Of course, near, right? If you're placing audio, video, and DSP near to each other, so routing becomes what? Easy or not? It will lead to what? Shortest path connection, shortest communication. So that will improve what? Timing, right? It will reduce what? Delay. So that will help in performance. So placement will also help us to modify or the vary the performance also, improve the performance also. Not only this, if it is placed far from each other, right? Suppose these logics, these two logics, logic 1, logic 2, belongs to audio system only, and it is placed far from each other. What will happen? The net length will be more, delay will also increase, also it will insert more buffers. Logical. So the overall power will also get dent, right? Also, what will happen? Delay will, so performance, power, and the utilization, three will get affected. Understood? So very important stage in placement with respect to PPA optimization. Very important. Understood this point? So this also we will discuss in very deep. We'll take at least 1 month in discussing placement and STA timing. So we'll do parallel discussion. That is for 1 month. 1 month we are going to discuss floor plan only. Only one full 1 month, 1.5 months will be for floor plan. More time will be given because floor plan is the main and very important step. If you are doing it correctly, you will face less challenges in placement, CTS, and routing. If floor plan is wrong, right? I can give you one example. If floor plan, you are placing memories like this, right? Some memories, if you have placed in between also like this, what will happen? So if you are placing here, right? Once you are in placement stage, you are going to place what? Standard logics, right? It will be placed like this, right? So what will happen? Lot of routes will go through this channel, and there will be a lot of detours. Yes. So due to this detour, lot of track utilization will be there. What will happen due to this? First of all, it will lead to congestion, right? You will see high amount of congestion rise. If more amount of congestion is there, what will happen? See, congestion means what? Traffic, you see, right? If more amount of vehicles go through same road, what will happen? Traffic jam, right? Here, if there are limited amount of tracks, more amount of routes are going through that tracks, what will happen? Shorts, right? See, unnecessary there will be routes will be created. Definitely, it will lead to more shorts or opens also. If tracks are not available, how tool will create the route there? It is not possible. So it will lead to opens. So this will lead to high number, so congestion also, and that will lead to high number of DRCs, right? So floor plan is very important step. That is why we give 1.5 month to explain you floor plan here. There are so many things to explain. Each small things are very important. If you miss that, you will face a number of challenges in placement, CTS, and routing. So very important stage. So that was placement. Next is CTS. So CTS is basically once your every logic is placed, right? There are sequential logics also. You need to route clocks. You need to provide clocks to all the sequential logic. But important thing is whether from ports all logics will be directly clocked to single routes or multiple routes or in branch. Right? That is important. See, one possible way is that you have a clock port here and you have logics somewhere here. How you are going to provide, these all are sequential logic. Whether you are going to connect like this This is clock port, right? This is not a good idea, right? Better is if it is clocked with same clock. So all logics are here. Better is from this, right? You can draw one spine like this. Let's say spine means what? Or you can say fish bone. You have seen fish bone, eaten fish, right? If you see the fish skeleton, right? It will look like this or not. Tail is like this, huh? So there will be skeleton, right? Like this or not. So if you see this skeleton, right? So this is the spine of that fish. If you draw the spine, right? And then you draw its ribs, branches, right? Like this. So clock will be coming from here. It will be distributed in this way. This is better or this is better? Which one is better? Second one is of course better. So what we understand, CTS is not only the purpose is not only to provide the clock to all sequential. It is also to provide with a good optimization also. Yes, I will not use those terminologies because everyone here. So of course, so I'll say that delay will be reduced, right? So skew or we'll say latency is nothing but the insertion delay. If you want to reduce the insertion delay, if you see here, so it will be like taking more routing resources, right? So delay will be more in this case and delay will be less in this case. And if you see compared to this one, this is quite symmetrical in nature, right? It has, if you draw a mirror, right, it is a balanced and it is symmetrical. Like that in CTS we have multiple number of algorithms also, like H tree, right, X tree, pi tree. So we have fishbone. These are all. So this is a fishbone. The example which I have explained here, it is a fishbone. Similarly, we have a H tree which will be distributed in H pattern. Okay.
You explain all this
Everything. Don't worry.
in terms of lab.
My class is theoretical, completely conceptual understanding and teaching you everything what is going on in industry, and I will relate it with the basics from starting from CMAS, which everything I connect by teaching. Lab other trainer will be there whose work is to explain, of course, with respect to lab, bound to lab tool, tool issues, some file issues, file is not readable, some errors, some mistakes, you haven't followed some flow. So there are many things in lab also. So those things will be taken care by that person. The EDA tool related things. This is CTS. So last but not the least, that is routing. So once you have clock is physically routed, the last thing which happens is the signal routing. So power is already done in floor plan, right? Clock is already physically routed in CTS, and finally signal routing. Okay, clear? Signal routing. So when we are saying routing means what? Is it a logical or a physical creation? It is a physical creation, right? Physical creation means what? Physically it will be present there. It is no more logic. Once we are discussing physical design, everything we are creating there physically, right? Which will be reflected when it goes to foundry, when it is fabricated. Whatever you are designing in physical design, that will be reflected in foundry, after it is getting fabricated. So in the complete, so this is for signal routing. In the complete design cycle, I will tell you. In the complete design cycle, 60% of 70% of time is consumed by physical design. Something around 30% to 40% is consumed by front end. Front end means RTL, DV, right? And physical design sign off. All these 60% to 70% of time is consumed. Means because there are so many things that major chunk of time is required for physical design only. You have to take care of both physical aspect as well as logical aspect. It's not like sometimes what will happen. I'll give you one example also. Sometimes what happens, so in routing stage, right? You have two cells. Now there are some tracks. Okay. Now there is one layer, M2, right? And this is M5. M5, and this is M2 again. This is M5, this is M5. So these two cells are connected, okay, using M5, M2. Now there is M2 also, okay. Now what is happening? Somehow a wire is dropped here. This is a wire. Now this wire is connecting this M5 with M2, okay. Now what is the problem here? Is there any problem? Yes or no? It is connected. Basically, what I'm trying to say that M2 and this M5 is connected. Now, what is the problem? It is a problem because it is a net, some net, right, which is connected to different net. See, this M2 is connected to some different logic, right? Unless and until it is meant to connect, there is no problem. But let's say two different nets are there and it is connected somehow by one wire which is dropped there. What will happen? Short between two nets, right? So that is what you need to take care in routing. So if you are getting that short, right, what will happen? What will happen? Logical failure or not, right? Your LEQ, logical equivalence check, will fail. Means functionality will fail, right? See, you have box like this, inverter, right? Suppose these two are short, right? Or let's say these two are short. What will happen? Logical failure or not? Functionality failure or not? See, this is only in terms of logical, but physically during routing, anything is possible. We don't know the tool algorithm, the iteration, how it works. So sometimes it may lead to unnecessary shorts. That also needs to be fixed by physical design engineer, right? It is our headache only. Okay. So logical failure is there. See, that's what I'm trying to make you understand, that you should not only take care of physical aspect, physical as well as logical, both has to be go in hand.
LEQ, LVS, LVQ.
No, LVS is layout versus schematic. It is a layout. What is your layout netlist? What is your schematic netlist? So two netlists are compared. Logical equivalence check will check with respect to the outputs. And netlist is comparing what? Not, we cannot, it is a, there is a term logical equivalence check. That's all. It is checking functionality. Okay. Any questions here? We'll stop here. If you have any queries, you can ask me. One more thing I told you that I will explain you. So once routing is done, so I have already told there are three sign-offs. One is timing, power, and what we say, timing, power, and what that physical verification. That is part of power only. EMIR is nothing but power check. Okay. Time. Yes. Signal integrity is part of timing check. Okay. We'll say so NDR is basically based upon this. There are two issues, EM as well as crosstalk also. Crosstalk is related to timing, whereas the EM is related to power. This is what you are telling, signal integrity. So timing, power, and physical verification. If these three sign off are passed, then we will say that it is good to send it to tape out. Clear? So many things, it's very difficult to like cover, touch each and every point. Okay. So one more point I need to add, which I have told that I'll tell you in the end of session. So regarding companies, many people have doubts related to companies. What are all different companies? So basically this is segregated into three categories. One is fab-based company, one is fabless company, and third one is your EDA-based companies. Fab-based companies only focuses on design, right? Only design. Fabless, so sorry, this is written. Fab only focus on manufacturing. Manufacturing, right? And fabless only focus on design. EDA only works on tool development. Not only they works on IPs also, implementation, development, tool development, implementation support, right? Basically tool development, and some EDA companies they work on IPs, libs, right? Fab their own design and its manufacturing. No. I'm telling only fab company. Only fab means they are only for manufacturing. Yes, fabless means only design. Now there is, you can say another type which is fab plus fabless. Right? Means it does design and manufacturing both. Like what? Intel, Samsung. Right? Fabless, Qualcomm, AMD, Nvidia. So there are many fabless company, right? Fab-based company, TSMC, UMC, Global Foundry, right? So these are purely fab company. They do not do any kind of design work. Okay. So these are major categorization here. So if you go for foundry, yeah, so for foundry also they will hire different. So basically, PD has a good opportunity in foundry based companies because they can more correlate with the physical aspect which they are designing in. So even global foundries or the TSMC, they will have physical designers also, right?
But what will be improving technology development sector?
They will not design things, so mostly they will help to calibrate data or the design which is coming. So the design which is coming from physical design, right? So some person is needed there also to understand that. So I'm not much sure on that because I have never worked in fab company. So like, but they will, I have seen that they will also hire physical designers.
Yeah.
Okay. Any queries? Apart from this, one more segregation is there in these companies only. Now companies are segregated in service-based companies, product-based companies, right? Now there are two types of companies, service-based and product-based companies. So service-based companies' role is to provide resources or services to the product companies. So there is no difference in the project here. Product is one, right? But sometimes what will happen? Product companies do not have that much of resources to work on that particular product or project. It is so big product or so big project, they need more and more resources. For that reason, they will go to service-based companies and they will outsource some work. If they are outsourcing that work to service company location itself, that is called as ODC, right? ODC project, offshore project, we'll say. Or if they're sending the resource to the product company, right? Sending to the client location, we'll say, right? So that is not a ODC project, that is a client project or a client-based location-based project, right? So project-wise, there is no difference, project is same. Work wise is also same, tool is same. If you are following the product company project, flow is same. So work wise there will be same. So what will be the difference? Difference is the pay. So if you are a direct employee to a product company, your pay will be higher compared to the service companies. If you are in a service company, the pay will be comparatively less to the product company. Why? Because the service which is provided by the service companies, the payment is going to the service companies. From there, it will go to the employee. It works like this. Okay. So this is about type of company and different type with respect to the VLSI also, that I have explained in last slide. Any question? Okay. So if you have any question, you can ask related to course structure, timing, or company job opportunity. Your class will start, you need to check with the schedule manager. You can check in ground floor. They will tell you.
So for PD, you will be
Hmm?
for PD, you will be the tutor for that course.
There are other trainers also. Not sure whether I will be. I will be demo. Yes. So I don't know that time what will be the scenario or availability. I even don't know when your session will start because 2.5 months will be for basics. So not sure because there is some fast track. I mean the base batch is there. So for them, it won't be for maybe demo for you are attending same class, but base people. So possibly who is next advanced session which is going to start. The I you can check with manager only that slot and schedule when new session will start. They will only decide. You can check with them. I think every month there is a new batch. Every month, or yeah, mostly. Date wise, I am not sure, but every month there will be a new batch. Yes, any queries from online side related to institute?
Hello, sir. Am I audible?
Yes, yes,
Sir,
your
I've heard that
name?
your Suresh.
Yes, Suresh, tell me.
Sir, I've heard that you are planning to open institute in Hyderabad.
Okay.
In the month of January 24th, it seems. So if
Okay.
I plan to take for online coaching, I mean online coaching. So then after that offline, I mean when offline starts, I will join in offline batch, sir. So from that day, I will start with the same new batch, or my course will be continued from the where I have left.
Once you can check the schedule thing with manager only, like how dates and these things. Dates wise, whatever questions related to dates wise, when it will start, when I can start, all this you can discuss with manager.
They are not responding properly, sir. Sir, they are not giving proper information.
Okay, you can. I will check with them. No issues.
Sure, sir.
Okay.
Sir, one more thing. So we need to take a lab. We need to have laptops also, no, sir. So what are the minimum specifications to run these tools in a smooth way?
I am not sure about the minimum thing, but I have used in dual core processor also. I've worked, means I've used this ICC2 Synopsys in dual core, but right now I don't know. They might have updated the PP or so at least I think you will be having i3, right? i3 level processor is there. That
Yes,
is
sir. Yes.
fine.
So
No need
dedicated
of
graphic card is
i7.
developed.
Questions here.
There is
Here
no
only.
need to have any graphic cards like gaming laptops and nothing.
No, no, not required. See, even if you go into company, you don't require any graphic. See, company anyways, you don't have to purchase laptop, first of all. But I'm taking for an instance, you do not require such high-end laptops unless and until you are a professional gamer. That is, you purchase any laptop, good laptop in 50,000, that's done. Why to purchase 1 lakh? See, I'm an electronic person, but I'm should not say, but that is the thing. Because every 4 5 years, the technology will be outdated, right? And it will be slower also. Why to invest so much of money in high graphics and these graphic professional thing? Unless until you are a professional gamer, you are winning something in dollars, playing some in competition and something, then it is a different case.
So we are not looking for a gaming lab, sir. Only for having these tools to run smoothly.
That's fine. I think i3 is sufficient. With 4 GB or 3 GB, 2 GB RAM is also fine.
Okay, okay, sir. So here I've heard that AMD Ryzen processors are a bit have some heating issues compared to Intel.
See, 3 4 years, you will not get any issues in any laptop. You purchase anything.
Okay,
But if you want, I already told, in terms of reliability, in robustness, Intel processors are better compared to AMD Ryzen. Performance wise, AMD Ryzen's are giving more better performance in less cost, cheaper rates. But something has to be compromised. Everything you won't get.
yes, sir. Yes.
And fast.
Hmm. Usually, I will choose reliability only because
Yeah, for our requirement,
So in
that's
terms
all.
of reliability, we need to choose Intel.
I'm not saying like this. AMD is also good. There are also premium chips in AMD also, but you have to go with higher price then. So Intel, if you purchase i3, I think it is more than sufficient. Instead of going i5 also. If you have a budget, you can afford it. Of course, you can go for i5 also. It's your choice.
Yes, sir. Budget is around 40 to 50,000. So we are not. I mean, I'm not aware of
You
what.
go for
What are
I
the,
i3, you will easily get I think 40 to 50, right? Lot of good laptops are there. I think 4 GB RAM also you will get in that budget. Mhm. That's in Ryzen it's cheaper, like I said. Ryzen this. Any other question? Okay, then we'll stop here. Thank you, everyone.
Sir, about the fee structure and all those.
Fees you can discuss with the manager. Fees, schedule, dates, these two things you can discuss with manager. Subject, course structure, right? Jobs, opportunities, you can discuss some questions I'll answer with respect to placement, opportunities and these things. But dates, fees, you discuss with manager.
Okay, sir. Sir, what is the scenario and the placement for physical design, sir?
So
Usually
from
people.
past 2 years, so placement is not that much. I will tell you truth on. I will not tell anything fancy things. So placement is
Okay.
not that much good. Recently, Synopsys also laid off many people, if you know, right? Not only Synopsys, many big product companies. That is the biggest disadvantage in product company, I will say. Of course, the pay is more compared 3x more compared to service-based companies, but it comes with a big disadvantage. My friend in Synopsys, he was getting paid around 30 or 40 lakhs, around 35, I think. So he got laid off. So why? Because having a high amount is more vulnerable actually. So product companies will not think a second thought also before removing. Why? Because if the market is down, first thing they will start doing in budget cutting is removing the resources which they have, which is on high pay, starting from the top. So 1 CR, 80 lakhs, they will be removed first.
Okay.
Like that they will.
Yeah, but they will look for the bandwidth allotment, right? I mean, how much of the effort is being used in the project. Let's say if it is overlapping with something else, they will remove it.
All this HR story that is they will give, but that is not real thing. Real thing is they only care about if their market is down to save the profit, to crunch the budget, so they can do anything they want. They will not think about what project is going on, not going.
Critical because they will break up.
All thing comes in one circle, that is money. If project is going to bring that more profit, in that case they will consider. If that project is not that much of project, they will even can drop that project also. If small profit means they will not care about project and resources, they throw everyone. No, don't have emotional attachment with any company. No, those are not, corporates are like this only.
Have you worked in corporate also before this?
Sir, what
Think
central government is planning to do is to expand the semiconductor industry in India. So we have heard that there are many job opportunities will be in the future in upcoming 3 to 5 years. So how far it is it true, sir?
See, the job opportunities, I will tell you, it is closely related with two things. One is the consumer demand, the first thing. Second thing is innovation. And that consumer demand is directly proportional to innovation. If innovation is not happening every 1 year, 2 year, obviously consumer demand will also go low. Suppose you are using one phone, right? You're using 50 megapixel camera. You are happy with that 50 megapixel camera for 5 years. You don't want more than that. And there is no innovation also. Above 50 megapixel camera, there is no innovation. I mean, there is no 80 megapixel or 100 megapixel, no innovation. Now, what will happen to consumer demand? Obviously, it will deteriorate. So if that deteriorates, so whether the profit rate percentage, the growth rate percentage of any company will be same, it won't be same. So it will be stopping there, right? Whether they will require same amount of resources which they are paying in lakhs, they won't require. They will cut down those resources first, right? That is all, these all things completely depends on the demand only. Now coming back to your question that whether government is giving a positive outlook on that in coming 10 years, so it is not government only, even in Forbes magazine, if you see, they have given economic prediction. Even in Outlook magazine also they have given that it is a good sign that VLSI will grow in coming 10 years by 2030, 2030 or 20 something, they have given some year. right? So by that time, this will become $40 billion market or something. So how they're predicting, mostly it seems that it is depending on the innovation which is coming up, like AI based chips are coming up, right? So in future, you might see your phones, your automation, your cars, everything will be having the AI based chips. So that new innovation will also create new consumer demand. So that is how the prediction goes. So if that increases, definitely the opportunities will also increase. This is one thing. Suppose the So there is also one thing that is called as monopoly. So major players are these Qualcomm and these others. There is no local product companies which is in competition with those companies, right? That is also very dangerous with respect to the prediction we are making. So recently you might have seen one example, that is Indigo Airlines, right? Indigo Airlines shares means they share a 60% of market, 61% of market of India. Moment they stop their operations, right? So what happened? Collapsed. Everything collapsed. Right? System collapsed. They have to kneel down. Monopoly is very dangerous. If having a single company or some company in that sector is very dangerous. So the local or the Indian-based product company, if they grow in competition with them, then that is very good and advantageous for us, because then
Yes,
we
sir. It
will
is
be
just like telecom companies.
any means. I'm
Mm.
just my point
Mm.
is that only that there should not be some competitors. There should be many competitors. So more the number of competitors are there, more competition is there, more opportunities are there. I'm telling with respect to your perspective only, not with the company's perspective. Companies will think about their profit, but our perspective is that we should get the opportunity, and that will be ideally the best scenario is when we have local grown product companies which can give competition to the global market level. That is the best. If government is saying something like that, it is always welcome, but it should be in correlation with how much support the local product based companies are getting and how much help they are getting in growing at par with the global competition. That is very important. And of course the consumer's mindset is also very difficult to understand. Market consumer mindset is different in India. You also know that, right? You're going to purchase one phone, right? So without, now even a village people will tell that I want the iPhone, whether he knows what is there or not, how it works, what are all features, but blindly that person says iPhone. How? That is market brainwash, right? Consumer brainwash. So that is also very difficult part to play in. Even a good product, local product company comes into competition, it is very challenging for them to survive because of these kind of consumer mindset also. So even it provides a good quality, so people will be hesitating to purchase it because that mindset is created in the masses. Decision making power has been taken away from the consumer. Decision making power means what? You are using your brain and seeing all the specification features. Okay, this is this chip, it is how it is fabricated, and then you're purchasing. That is your decision in your hand. You're not driven by some market strategy.
Sir, what about DV role, sir? I mean, DV and PD.
EV and
I mean, DV and PD, because a few institutes tell that DV has openings throughout the year, and only PD has only for the particular
no,
two
it's
to
not
3
like
years.
that. There are no openings. There are right now also there are a lot of openings in physical design. Yes, yes.
Sir, your audio is cut, sir.
You can ask this. He is the manager. You can ask him. Okay.
Yeah.
So
Hi, sir.
fresher. See, I will tell you simple way. For freshers, right? The more number of opportunities are there in the service companies. Product-based companies do not have that much of opportunities. So they will hire in single-digit number, max 2 digit. I haven't seen much unless and until it is the tier one college hiring is there. The fresh graduate directly from college, NITs or IITs, they'll hire in 2 digit numbers max. That also 3 digit never happens in college also. Okay. So if they're hiring off campus, so it is a single digit number. But in service companies, they hire in 2 digit number. Usually, most of the time it is seen. Right. So for freshers, if you are not belonging to tier one college, it means IIT, NIT. So all other colleges have good chances, good opportunities in service-based companies, right? And the openings are usually in 2 digit numbers. So there are companies like TCS, Wipro, Infosys, Insemi. Insemi is now become Infosys. Excel Max has become Accenture, right? Sankalp Semiconductor has become HCL, right? Infinix, I'm not sure. Infineon is there. So earlier it was service-based company, now it has become product-based company. Like that, every service-based company is working in their own self projects also. Moment they get resources and good this infrastructure, so they start working on product development also.
Sir, does this VLSI Guru has its own company working parallelly?
That you can once check, right? See, we are not working in design based company. There are some projects and some design based work which are going to be done, but yes, so VLSI Guru more importance or more focus is on training aspect, making you ready for industry level.
So making it very my requirement is
So,
I want to be uh, in the industry as an experience of that. PD experience, not like just hands-on experience to be introduced to the industry.
For experienced person, if you are already in domain in physical design, there is one-on-one sessions are also available in this institute. One-on-one dedicated session is available, but it will be of higher price. I'm not sure. You can.
Just leave it on page.
No, I am
Actually, we
not
are
sure. You
not
can
in
check.
a domain, sir. So we are
What is?
actually few people are there in not in domain. They are in in the stage of learning. So how does your institute will help us to get into the industry?
I have explained, right? Course structure. We'll start with PD basics. Even if you have forgotten the digital concept, CMOS concept, 2.5 months of dedicated time will be given for basics, where GVim, tickle scripting, Linux command, whatever required for skill development, it will be taken care in basics. Test, continuous assignment giving, question and answers, right? Mock interviews. In every aspect, your skills will be developed.
In VLSI Guru, we will be working on 14 nanometer technology, sir.
We have both 14 nanometer and 28 nanometer technology node. So your project will be on both. It is not like DV
Actually,
has more opening or PD has more opening. It depends on time to time. Sometimes PD openings will be like anything. We cannot generalize this.
After this course, after this course, I mean, let's say, how much of experience is equivalent to this course only?
How much?
Like, how much?
So you will be not treated as a fresher after this course. You will be called as trained freshers. That is the differentiation between a graduate and between you. You have a upper hand because you know how to use EDA tools. You know the full flow. you know the terminologies of physical design, you know how VLSI works. So that is your upper hand in terms of comparing with the fresh graduates. So obviously companies, service-based companies or product companies will choose you.
Sir, you will be the tutor for physical design.
That I cannot confirm now because it depends on schedule and availability. You can check with manager whether I will be available or different trainer. Will there be any placement support for people in US, like any reference, etc.? I think there is support, placement support for people who are studying in US or working in US also. So there in past batches, there were many students who were from US and from European countries. So those people have been given with the placement support also. You can check more about this with manager. Studying masters in US. Okay, it is fine. So the things are there. Yes, any other question?
Sir, actually, I asked
Because I'm being
about VLSI Guru has its own company. So because a few institutes, your competitors have their own institute. I mean their own companies. So while during the placements, if the student is not placed in any of those companies, they will hire for their own company. So that's the way of asking.
no, but why you are thinking about this? You should always think about the best, right? How much best I should get. I'm already telling that we also have our own company. But I will tell you that you should go to company where which they are working on dedicatedly on physical design. Yes, here also we are having project, we have company, right? Here also you can learn. But what is more important? Learning more importance, right? Learning in the real time, more difficult project is more important, right? Getting a good pay is also more important, right? So that you should say. Yes, of course, those kind of support is also there in this institute. Okay, thank you everyone. I hope we'll meet in sessions. Can I have your LinkedIn? Oh, that I cannot share. Okay, thank you everyone. We'll meet possibly if you join the course and I'm allotted for your session, we'll meet again. Thank you.